Well, hello everybody, and welcome to SkyTour LiveStream on October 9th, 2020. And we started a little bit later than I wanted to. I wanted to start it at 9 o'clock, but I was working out something. I worked out a new feature for the observatory. It's always about adding some new functionality, new features to try and make the observatory run more autonomously, by itself. And the new feature was, as we talked about before, those filters up there that you can see that one spot, that the filters that go here in the filter wheel section, which I will show you because it just went away, right here. Those filters up there, when I go to the different filters, it's a slightly different focus in the telescope. So I have it set up now so that it will auto focus between filters and set the specific focus for each filter. So you get one good focus calibration, and then all the others are off based on that, called an offset. And so far it was working, but it's temperamental, and I still have to talk to the guys who wrote this product to see if they can fix the problems or if I can use them in a different way. But either way, it's still progress. I want to say hello to Martian, who's here. Terry Groff is here. Gina Leone's here. Hey, how are you? And Cheryl Texas is here. And Gaia Savelas, how are you, man? It's good to see you here. And of course, Daryl is here along with me. And Tim F is here as well. Tim F was the first one in here, not counting Daryl. So, how are you guys? How's it going? And how's the world treating you all today? And lest we forget, Marianne is here as well. Hiya, Marianne.
Hi, Marianne. Hello, everybody.
Yeah, and since Marianne is here, I think it's probably a good idea to give you a little update. The observatory, if you recall, the Arizona Observatory, we actually had a problem with the previous contractor, and we basically had to fire them, unfortunately, after thousands of dollars of investment, and we ended up getting most of it back. And now we actually have a good contractor, I think. Marianne is comfortable with this guy. I'm comfortable with this guy. I talked to him twice so far in the last couple days, and he is all about getting us an observatory that we're looking for, and he's going to build it custom like we wanted. So it looks like we have a contractor ready to start next week. So SkyTour LiveStream West can have its building by next week. And it's so exciting that I'm not sure I can contain myself. Excellent, Gaia. So I think that, and hi, Brandy, and I know that, let's see, who else came? Oh, Bob Harless came in. Hi, Bob. Nice to see you guys. Yeah, tonight we're going to be looking at a few things. I actually have something in here now. I'm doing some testing. I mentioned earlier, a moment ago, actually, that I'm testing getting this to focus in between filters. When you go to the next filter, it requires a slightly different focus. Okay, and as you can see, this isn't quite right. That's all right. Getting this set up to work right every time is just is not expected in the first run of things. So this is the focus for the filter that is just the pass through. Okay, when we actually look at where we are, okay, you look up above here, all right, and right here, you see that it says pass through right up there, and pass through is it means it's just there's no filter in there, it's just a hole and it's looking through. So what I want to do is I want to go back to filter number 2, which is our narrowband filter that's a little bit wider, and we can hear, it's hard to hear through the headset, but you can hear that the telescope is focusing and refocusing the settings out there. So you'll be able to actually see that it's actually focusing, which is good news because it should be focusing when I change the filters. And so it's doing so, and that's good, but it's not working every time, and that's what I'm troubleshooting. But not to worry. So I've gone back to that. I went back to that special narrowband filter number 2, and so I'm going to take a 10-second shot of this globular cluster to see how it looks. And look at that. It looks beautiful. So you see the focus does work when you want to get to work. Look at that. That's a beautiful, beautiful globular cluster. I believe this is M2, if I'm not mistaken. Yes, it's M2. It's also NGC 7089. And it's a beautiful globular cluster. And if you're interested in knowing where it is, well, in the sky, it's actually in, where are we? We are in, I believe this is,
Aquarius.
I think it's in Aquarius, that's right. And this is Aquarius, the water bearer there, you see him. And the other thing I'm working on is getting my scope setting to line up with the object we're on. It used to, something changed. I'm not sure what it is, what's happened. But, so M2 is here, and it looks pretty good there. And we want to probably, let me just go back to this. We probably want to at least try looking down here. This is another object that's really interesting to look at. It's called the Saturn Nebula. And we call it that because it sort of looks like Saturn. So we're going to go there now. Okay. And when we come in here to the main view here, you may see stars coming and going in here, which is to be expected. And we're going to line up on one particular star. I got to make sure that I might not have actually told it to go. Yeah, I think I didn't tell it to go yet. Hold on. My mistake. I probably should have told it to go. All right, and I think I told it to go now. How do we know? Because we see a star moving into the field. This is a star that it's using to find where it's going to be, located off of. And from there, it will go to the Saturn Nebula once it aligns that star, pulls it into the center like that. And it will only be there for a short moment, and then it'll zip away as we head from this star, as the telescope will hop us down to the Saturn Nebula. Okay, and so we'll wait for a second as it's doing what's called auto-centering. There it goes. Brings it over, auto-centers right to where it says, okay, I'm there. And then boom, away it goes. And we should see the Saturn Nebula sliding into view. It's sort of an object we could see here in the telescope. And there it is, right there. You can see it coming in. I don't know if you can quite see it right there. It's inside that little circle I'm drawing. Okay, so the Saturn Nebula is visible. And what I'll do is, in order to image this properly, we want to do something like bring down this sensitivity. So I'm going to bring it down to just about, say, we'll try 320, and we'll do it for 8 seconds. And it'll hopefully bring in just enough so that we can see some of the structure within the Saturn Nebula. All right, so I click the button here to go, right next to our SkyTour LiveStream logo. And there we go. There's our Saturn Nebula. Where? You didn't see it. I know it seemed like so quick, but it's right there. And I'm trying I'm just doing what little I can right now to actually bring out some of the details so you can see how it looks. And I'm not exposing long enough to actually show you why it's called the Saturn Nebula. But I'm about to do that for you next. Here we go. And now we come back to this. And now we'll go and say maybe 20 seconds at ISO 320, which is the sensitivity. First timers, this is the sensitivity of the camera. This is all camera control here. And 20 seconds is the exposure time. On the left, we have our telescope control system up here. We have me down here. Daryl's invisible. He doesn't want to be seen. It's like that Monty Python skit, Daryl, where you...
The one about the leper?
No. It's like, Daryl Mason has chosen quite a good hiding spot. He knows how not to be seen.
Hey.
Frankly, though, we know he's hiding behind the bush, when they blow up the bush.
Unclean.
Yeah. So that's it. So now we're going to do a 20-second exposure here on the Saturn Nebula. Hello, Carol Carl. It's nice to see you here. Technically, I see you, but not really see you. Okay. So you can see some
blue.
Yeah, it is. It's a beautiful shade of blue, and you can see some of the detail in there. Again, I haven't gone deeper into it yet. I'm still looking at the possibility of doing something like this, bringing up the ISO here. Let me bring us back to our main screen for that. So I'll take us up to, say, 1250 for 20 seconds on this Saturn Nebula. And the higher you go, you'll start to see there's more details that come out. And that's what's really cool. You know, that's what's really cool. Yeah, Martian, the nebulae like this look a little bit like smudges. They look like, the reason they're called planetary nebulae, which is what this is because in the eyepiece they could be mistaken for a planet that's faint. Okay? But this guy, all right, you can actually see, I'm going to actually try to see if I can do some focusing on this. It might need to be focused a little bit too. And to do that, I'm going to go find a bright star nearby. And then we will focus on that star. Well, actually, maybe what I can do is I could focus on the nebula itself. All right, let me bring the nebula down a little bit.
Are you on the number 2 filter?
I am on the number 2 filter.
Okay.
When Daryl's referring to the number 2 filter, he's I can't focus here. I'm gonna have to go to a star. What he's saying is, in our filter wheel up here, we have 5 different filter positions. Okay, the first position is narrowband 1, and that's looking at narrow slots through the spectrum. The second position is narrowband 2, looking at slots in the spectrum but slightly wider spaced. Okay, and I'm gonna fix my camera so it's not doing that to your eyes as I talk. Let me just do that right now.
Number 2 is a jumbo shrimp filter.
That's right, the jumbo shrimp filter indeed. That's exactly right. Yep. Yeah, because it's a wider narrow band, so that's why Daryl calls it jumbo shrimp. You know, Carlin says, "Oh, you don't know what's going to arrive, either a little jumbo or a big shrimp." You know, he says a big shrimp or a little jumbo. All right, so let me.
I can say the 7 dirty words you could never say on television, but you'd probably kick me off the stream if I did.
Well, I wouldn't, but I can say them too.
Yeah.
I mean,
all right. I have it memorized.
Me too. Just to be a kid, you got to be able to say those, right? You know, back in the day, right?
I got old George Carlin albums out the wazoo.
Yeah, me too. Class clown, all that stuff. Oh yeah, because that was me. I was a class clown. I was Mr. Class Clown. All right, let's see here. Let's get this to. All right, that makes my hair look orange. That's good. That's fine with me. There we are. Okay. Now I should be able to point and not have any problems. See, a little better. A little better. I didn't say it's perfect. Okay. So, yeah, number 2 filter, 1200 ISO, 20 seconds. That's 1250 ISO. But yeah, and that's with the narrow band number 2. And what I need to do is I have to set up my. I want to get my focus correct, so I'm going to actually pull in a bright star here, which is over here. I see one. And then we'll go back to the nebula in a minute. Okay. This is to set up. It's the first thing you're supposed to do at night anyway, is to, make your get your focal plane setup. Okay, so here's a star we're going to use. Yeah, I'm going to head west a little bit. All right. Now I'm going to focus on this. So take it out of focus. We saw we just went into focus and then back out. It's always a good practice to go past the focus the first time, because you have to get good at seeing where focus is. And focus is, in this case, where it is the smallest image on the screen, which is kind of hard to do when it's dancing around. But let's see if this actually helps us out. We'll come up. Okay, let me go east. Let me go east, young man, and bring us to our beautiful nebula once again. There it is, right there. And let's do another 20-second shot at 1250. We're waiting the obligatory. We wait 11 seconds for the guider system to latch onto a guide star in that field somewhere. And that's it. After that, off we go into the wild blue yonder. Well, wild black yonder, I guess. Okay. And here we go. And let's see what we have. That's right down here. Okay, so pretty much the same. But the Saturn Nebula has these appendages on the side that you can see, kind of like the planet Saturn does. And I'm going to see if I can draw out more detail. We're going to go to 3200 for 20 seconds now. And you just go right back into that. Okay. So
I think they call the sides NSAE, just like they do on the rings of Saturn. NSAE.
Okay.
Means handle or ears, literally.
Yep. I can imagine. I'm actually not sure, but you can see them now. If we zoom in, you can see here that they're sticking out on the sides here. Okay. And I want to talk about that a little bit, because when a star dies, okay, and I'll go back and take a longer exposure to show those particular NSAE. We'll go to, say, 6400. All right, then we come back. And when a star dies, what happens is, you know, it uses up all the hydrogen in its core, and it's only that outward pressure from the fusion reactions that are actually holding the star up. It's fighting its massive mass, all of its existence. And as the star, well, satellite figures, as the star runs out of hydrogen in its core, which it fuses, the star is big. It's this gigantic ball of hot gas, but only in the very core is it generating energy to hold itself up. That's it. It's not doing it all out in the envelope. Our sun is a certain size in the sky, right? It's not actually doing anything to create energy in the outer part of the solar structure. Only in the very core of the sun is fusion going on, and then those photons that are generated from that, and the neutrinos and the other radiation that comes out from there, it's fighting against the other photons of light all the way out from the interior of the sun. To that end, a photon of light to leave the sun, it could take it many, many years to get out of the sun, but once it gets out of the sun, it reaches us in 8 minutes. Okay? It's not a clear path. The photon is absorbed by another atom. That atom is, not atom, but nuclei. And then that changes the nuclei. Then the nuclei gives that photon back off, and it keeps on going all the way until that photon finally makes it out of what's called the photosphere into the corona of the sun. And then it has a fairly good chance of getting here. So that's kind of cool, Now, when you look at this object here, okay, when we look at this thing, one of the things to understand, which many of you do now, is that we're seeing what's called oxygen 3. And Martian, you're talking about it as well earlier. This oxygen 3 is actually a element that was in the star's atmosphere. It could have been made in the star's core and then dredged up out of the core as the star got older. Or it could have just been made with this oxygen, this particular oxygen, and when it got left it could have had oxygen in its atmosphere, that is to say, its structure. And when the star finally bloated into a red giant at some point, then it started dredging up this material, and some of that outer envelope was floating away from the star, because it gets to the point where the thing swells so big that the outer envelope is just tenuously held by the star's former gravity, because it's so distended now. So the outer layers just need a little bit of an impetus, a little push, and they can just float away when it gets so big. That's when it reaches the red giant stage, and that is probably what happened here. And when we look at it, it just went away. That stuff blew off the star, and it made these concentric shells. If we were to look at this in detail, if we could get into this thing, we'd probably see there's shells in here of material that it came off in different shells, and it's like a kind of it looks like it's illuminating my face. But those shells were actually very discrete and made of certain elements. Most of the elements that came off of this star when it died was in the realm of oxygen, which we see. That's the dominant one that we see. And so that tells you that this star was not that much bigger than our sun when it finally died. And our sun has a similar fate awaiting it in about 5 billion years, so don't pack your bags yet. You're fine. Now, the question is, when you see these things here, how does the star make? How do we see these little appendages? Well, the thing that gives it its name, the Saturn Nebula. Why do we see those? Well, there's a number of things that happen, a number of reasons why those things happen. When a star is older, we notice that some of the structure of these planetary nebula, as we call them, are dependent entirely on what the star was doing at the point at which it became a supergiant. When we look at a star like this, it's possible that this was a rapid rotator, rotating very, very quickly. And if it was rotating very, very quickly, it could be that it started to spew gas off along a certain axis, and that certain axis could have been the equator. Maybe that's why this looks distended. This could have been a rapid rotating star, rotating this way, And if it was rotating this way, then it would tend to elongate along this axis here. Okay, and when it elongated like this, some of the material might have ended up kind of in a accretion disk, that is a disk of material going around the very star itself. And that could have caused this, just like we see it here. Those are all valid potential, And I believe, incidentally, to completely not quite change the subject, when we look at that satellite path you see right here, okay, you can actually see it's a dash and a nothing, and then a dash and a nothing. Is this aliens giving us Morse code? No. As one of you, I think maybe Daryl even said it, it's a tumbling satellite body. And that tumbling effect is, as it's turning, more light gets reflected over a certain point of its rotation, and then it shows up as a bright light, and then less shows up, and it shows up as the space in between the dashes, right? The darker lines. There's still lines there. They're just darker and less bright. But there's the Saturn Nebula and a beautiful tumbling satellite or rocket body. Now, because we know
Can I add something to that?
You may.
You were talking about the progenitor star that formed the planetary nebula.
Yes.
What's going on there now? The star collapsed on itself and became a white dwarf after it expelled the gas.
Yep.
And as the white dwarf collapsed, it spun up in speed a great deal. And it's also emitting a ton of energy. It's very hot. And I bet a lot of the energy it's putting out is in ultraviolet or even X-rays.
Yeah.
And That's what's causing the oxygen and the rest of the gas in the planetary nebula to fluoresce.
Yeah, as Daryl says, and he's absolutely right about that. When there's a white dwarf that's left behind, think about it this way: when a star collapses, it's like an ice skater bringing the arms close to the body. What happens when they do that? They start to rotate faster and faster, don't they? Okay, and that's what happens when stars collapse. All right, that's why when there's supernovae that leave behind things that are called pulsars, which are the hot cores remaining behind that were just crushed from all directions as the star collapsed, they're spinning very, very rapidly. Now, the record rotational rate is somewhere above 700 cycles per second, meaning 700 rotations every second. Now, that's pretty good for something the size of Manhattan Island. And 700 times a second to go around, and 700 times in a single second means that there's an awful lot of mass squeezed into that area because it has to hold itself together. Otherwise, it would just rip apart. And in the case of white dwarfs don't have those same kind of pressures, but they are actually very interesting because their surfaces are made of what's called degenerate matter, meaning that all that is left on the surface of the star are a lot of carbon atoms, carbon nuclei, I should say, and then electrons. And the electrons are not in the atoms. The electrons are just separate. And the reason that the white dwarf stays intact is because of something called electron degeneracy pressure. What's that? Well, electron degeneracy pressure is just, it's like, think of a checkerboard with all these squares. You can put one electron in each square, and you can't put more than one. When it's full, if you try to squeeze it in from outside, you can't crush it very well because those electrons are pushing back. And that pressure that they push back with is this pressure we're talking about. So on the surface of the star, you think of many, many trillions of checkerboards full of electrons, and there's just no way to crush them smaller unless you have a much more massive star to begin with. Then they could go past that pressure, all right, and become something called a neutron star. And when they get to become something like a neutron star, well, then they have another problem. There's another wall that's reached, and that wall is the one where the neutrons themselves are in the checkerboard boxes, and they're pushing back with their own pressure as well. Electrons, no. Protons, no. But neutrons, those neutrons that are left behind for a neutron star, those are pushing back with a vast amount of pressure as well, because they're filling all the checkerboard squares. And that way, that pressure will not allow compression. And again, for that to compress even further into what we know as a black hole, it has to be able to go past that threshold of mass that's required. Somewhere around 2.2 times the solar mass is about the largest neutron star that we can find out there. Beyond that, stars will go into black holes. Typically, they'll have supernova explosions leaving behind a pulsar, which is a very rapidly spinning neutron star. Or in very, very odd cases, they create something called a magnetar. A magnetar, I bet you know what a magnetar is, Daryl, right?
It's a great big magnet.
Yeah, it is, in the form of a neutron star.
Yeah. It has such an intense magnetic field, it would kill you instantly and probably turn you into mush.
I don't even know that mush would be something that could exist near a magnetar.
It'd certainly scramble your brains.
Well, it would actually disassemble all of your atomic structure in a heartbeat.
There you go.
Yeah.
Sure. Martian asked another question while we're still on Saturn Nebula.
Yeah.
We were talking about filters, and the number 2 filter in particular. We talked about doubly ionized oxygen, or O3, in that color. Yeah. He said, is it O2 then, or O3, or what? All the above, or more, or less?
That's a very good question, Martian. All right, let me explain what happens. Now, you would say, are the oxygen atoms ionized only twice, because that's O3. And just so you know, O1, it's O1, the 1 is in Roman numeral 1, O, and then Roman numeral 1. That's not ionized at all. That's the base state of an oxygen atom before any ionization. We like to confuse you. So, that's us astronomers, O2, on the other hand, Roman numeral 2, O2, that is singly ionized oxygen. Okay, so one electron has been popped off of the atom because of radiation that struck the atom, like ultraviolet radiation, and added energy to the electron, so it just rose to a very, very high orbit until the point where it didn't even have a connection or a attraction to the atom anymore, to the nucleus. O3, on the other hand, is when two electrons are raised to another state like that, where they leave the atom, and that's doubly ionized oxygen. Now, doubly ionized oxygen is one particular state, right? Yes, there's singly ionized oxygen as well, but what happens is most of the oxygen we see, the dominant transition that we see, is doubly ionized oxygen like this. Okay, now even there, in the oxygen atom, all right, the oxygen atom has a bunch of concentric shells around it that are electron shells, right? Well, if you have an electron jump off the atom, only when it comes to a certain location back in the atom, when it returns to the atom, only that certain location drop from outside the atom is going to result in this color. All right, all the others result in something slightly different. All right, and that happens. They're all happening all the time. But this one is the dominant one. It's the predominant one that we see, but it's not all that's there. So that question is extremely intelligent, Martian, and I want to thank you for that question. Really, really good one. Okay, so yes, when one electron comes off, that's singly ionized oxygen. But because when it has all its electrons, that's O, Roman numeral 1, O1, okay, this means that means O2 is singly ionized oxygen. Okay, doubly ionized is O3. All right, or it's like this.
Can I play devil's advocate?
You may indeed.
Well, not devil's advocate, but the oxygen itself. So is it molecular oxygen, O2? Is it ozone, O3?
Okay, well, if we consider that what you're suggesting is intact oxygen atoms, okay, then you would say, well, how could we ever expect to see ozone or some other types of materials, and would we expect to see them here? Well, the answer is that this location, for it to glow, means that it's hot enough that it's actually causing ionization to occur. At those ionization temperature potentials, you're not going to find too many molecules that can survive that. Maybe way out here, okay, maybe in some of the area around here, there may be some recombination and some bonding that's going on between oxygen out there. Maybe you'll find O2 out there in some cases, but it's going to be a very thin material there, or thin gas. You're not going to actually have anything we can breathe out there, for instance. And you have to look at the conditions under which, say, ozone forms, or O2. Just because oxygen atoms are near each other doesn't mean they will bond to each other. You've got to have something to help that along. And if the conditions are right out here in the ISM, or interstellar medium, at this point, then we would find that potential. We see, for instance, we know that on the surface of some of the moons in our solar system, we know that there's diatomic oxygen, O2. All right. On Europa, for instance, some of the oxygen that is liberated from the processes there can be diatomic oxygen. I'm referencing if I read a paper, it might have been in Enceladus or Europa, but we also see diatomic molecules on Pluto as well, because Pluto isn't a hot location. It's actually extremely frigid. But we know that in the cases like that, where you have an abundance of atoms, some of the conditions are right by which you can actually get these diatomic molecules. On Mars, for instance, we don't have O2. there might be O2, but it's very, very rare, and those molecules are very far apart from each other, so there's few of them in a certain volume, in a particular volume. So if we went to Mars, it's 98% carbon dioxide, which is a carbon atom with an O2 attached to it. Well, that O2 can't just be pulled off and say, hey, look, oxygen to breathe. Okay, you have to go through a process to make O2 from the CO2. And when the Perseverance lander gets there in February, which is not too long, it's going to bring with it an experiment called MOXIE. That's Mars Oxygen In Situ Experiment. And it's going to create oxygen, O2, from the carbon dioxide in the Martian air. And it doesn't do that by just saying, you carbon, come here, and pull the carbon off. It doesn't do that. In the end, that's kind of what it'll appear to be. But what it's really doing is it's taking two carbon dioxide molecules, CO2 and a CO2, and it's bringing them together to form CO, which is carbon monoxide, and it's going to form some carbon monoxide and some O2, and that O2 is going to get stored away, the carbon monoxide is released. So you see, we're actually going to be making O2 from the CO2. Why would we do that? Because if we're going to Mars, we can't bring all the oxygen for the return trip. We would have to make it on site. So MOXIE, the experiment that's going there with Perseverance, is the size of a car battery. It's really not that big at all. Okay, and it's a very small scale version of the much larger scale plant that would actually make the oxygen on a day-by-day basis. Now, so that's one thing it would do. It would actually make the oxygen to let the astronauts breathe. The other thing that's most important is that oxygen is critical to making rocket fuel. So we can get all the hydrogen we need from the soil and doing processes there. That's actually kind of the easy part in a sense. The hard part is the oxygen. If we can generate the oxygen, then we can make rocket fuel for the return trip. Because I don't know about you, but if I was going to Mars and I had to stay there for a year, I would want to know I was going to be able to get home. And so the astronauts that go are not going to be going on a one-way trip. They're going to be going on a round trip, and that round trip might take 3 years. But they're going to go because they want to explore the unknown, right? And if they're going to do that, then we should send our robots out there to do all this work ahead of time. And the Perseverance rover going to Mars as well is going to do something else. It's actually going to bring little pieces of helmet material and fabric suit material. And it's going to expose it to the Martian environment long term to see what the Martian environment would do to our typical expected exosuits that we're going to use on the Martian surface. If they break down through some weird process, we know not to bring those. We don't think that's going to happen. And Martian's right; it's a test lab. It's sort of like a test lab. The Perseverance, and of course, Perseverance is also going to have a drone on it. It's called the Ingenuity drone, and it's a helicopter which is going to fly and take pictures of the Perseverance rover from some altitude, looking around its surroundings. It's going to be the most, amazing sight. To be honest with you, I can't wait to see what's going to happen here. Sorry, Daryl, I've been going on and on. If you had something to say, I apologize if I dominated here, but go ahead if you have something to say.
It's all right. I'm the one that kept feeding your questions.
No, I like it. Those are good questions.
Oh, they were Martian's questions.
All right. Yeah, and it is MOXIE, Martian. That's right, MOXIE. You can look it up. There's a number of experiments on the Perseverance rover that are going to be kind of unique. First of all, it's going to be there's going to be like over 24 different cameras on this system. And if you recall, when the Cassini probe released the Huygens probe, which went down to the surface of Titan, as Huygens was descending, it took pictures, and those pictures became the descent camera footage that was turned into a movie later. You could see it landing. Well, the same thing is going to happen on Mars, and the descent camera will actually be able to provide an image almost like a movie of the landing of the rover once it gets down to a certain altitude. Really, really cool. I think it's a neat approach. And they're going to use the Sky Crane to deliver the Perseverance in the same way they delivered Curiosity. If you remember the Sky Crane, this aero shell, which is aerodynamic shell, comes into the atmosphere. This pops off the bottom shell, and there's a rover sitting in there. And then the aero shell starts to pay out a cable on which this rover is sitting. And it actually has rockets on it. And as soon as it gets to a certain altitude, those rockets all go off, and the rover goes down and dangles from this string, and this thing shoots the rockets off just enough to let the rover set gently down, and then the rover disconnects the cables, and this thing goes flying off into the distance and crashes. So that is interesting because when Curiosity landed, you actually saw the plume of smoke where the rocket the Sky Crane assembly crashed. You actually saw it. It was so cool. So hey, I think that's pretty cool. Oh, Carol, thank you for putting up the Moxie experiment link. Thank you. That's very kind. Yeah, and Kyle Lynch is here. Hey, Kyle. So yeah, so there's some really cool stuff that that rover is going to do for us and show us. That is very, very important. And I'm really looking forward to seeing the results. And some of you know I have a fleet of drones that I use for all manner of things, and I'm going to be hopefully helping out some police departments in Arizona with this as well. And I think it's kind of cool the perspective the drone can give you. You know, it's a very, very interesting perspective. That said, I think we should move on to another object, don't you, Daryl? He does. He has
Sorry,
to unmute.
on mute.
I know. That's okay.
Well, gosh, with all that Mars talk, maybe we ought to go look at Mars now.
Well, that's the thing that I'm trying to figure out now. If Mars is in a position that would be conducive to a view, and it's up for sure, and it's actually just about 35 degrees up, maybe 36. So I guess we could probably check it out. You know, we're going to be checking out Mars quite a bit, actually. We're going to look at Mars, and I really like looking at Mars, to be honest with you. I'm a big fan of that planet. I remember watching the first, listening to the first War of the Worlds radio show in replay. And I can understand why people really panicked. Because the way it was told, the way Orson Welles relayed it was just really frightening. I mean, they said it was just a show. They said it was a Halloween special. No one seemed to get it. You know, no one seemed to get it.
There's also a musical version of War of the Worlds, at least one. There may be more than one. And I can't think of the name of the guy, his production, but
Okay.
What's his name? Richard Burton is the narrator.
Okay.
And the Moody Blues and all sorts of people play on it.
Wow.
It's a pretty cool album too. And it kind of sticks with the Victorian theme of the original story.
That's very cool. Yeah, that was a really interesting story. And you know, when we look at Mars, like the other night, we saw what could be Schiaparelli's canals, the Canali. Okay, and the Canali, and I actually had to do a talk about Schiaparelli's Canali on a NASA's Unexplained Files episode because I'd done over 30 of those episodes, maybe even more actually. They got a low number, and I did a bunch of What on Earth as well. But I know that the Mars episode was one that I actually had to create some little props to show people, you know, the face on Mars and stuff like that. But I was also talking about the canals and the misinterpretation of the Canali. But that was very interesting. The other night we actually saw some of the dark features on Mars that look like Canali. You could see where it comes from if you're looking at it just from looking at a telescope. Really awesome, though. You know, so I'm really pleased with, you know, how Mars shows up. Now, as far as showing up well in this particular telescope, keep in mind we're a deep sky observatory. We're not a planetary observatory nor a moon-based observatory. If you want that, P&K Space Imaging does it, although I don't think they're doing it tonight. I was trying to find out from Keith and Paul whether they were going to be streaming tonight, and I didn't get a response. Usually that means they're not going to. But when they stream, they're the best. When it comes to looking at the moon, anyway, for sure. And they've got a camera system that's unbeatable when it comes to looking at all of those things. Again, we're deep sky, but we show you phenomenal things with the deep sky as well. So what I have to do, Daryl, is if we go back and look at our if we look here, let me just get us okay. If we look here and you get an idea of where we are, let me just do this. Turn on our. This is our observatory view here. Okay, you can see the telescope here in the dome. This shutter is facing out toward where Jupiter and Saturn are in the Saturn Nebula, which is actually kind of near Saturn, believe it or not. And at the moment. But I would have to turn it so the shutter's facing this way, so I have to go out and move the dome.
If you think it's too early for Mars and you have other objects in mind, by all means, let's.
Well, we should turn that.
Let's keep your shutter moves to a minimum.
Yeah, because otherwise you have to entertain while I go do it.
I'll try.
I don't have a problem with that. And we've got a lot of things that are out there right now. I'm going to go spin the dome around anyway, because there's a few things to look at that I think might be interesting anyway. And then I'll probably move it one more time to get to Mars as Mars gets higher in the sky. Okay, so entertain, if you will, the troops. They came a long way. Hey, Dalai. They came a long way. So, they're from all over the place. So you entertain them. I'll be right back, all right?
I'll try.
You will always try. You never not try. You're always good. I'll be right back.
Well, we'll see.
Yeah.
I'll just say the 7 dirty words while you're gone.
Oh, okay. All right, I'm back. I think that'll be enough for now. No.
Yeah.
I'll be right back.
No, I will not say the 7 dirty words.
No, you will not.
Anyway, give you something to chew on about Mars. Mars Day, I mentioned before, is just a little bit longer than the Earth Day. It's 24 hours. I said 40 minutes. It's actually 24 hours and 37 minutes a day. And what that means is if we look night after night at about the same time, say we see dark features. We've been seeing Syrtis Major a lot lately, and we'll continue for a while. But looking at the same time each night, Syrtis Major will be a little farther to the west. That is earlier than it was the night before. We see it march from right to left across the face of the planet at the same time from night to night. The planet itself, of course, is moving from west to east or left to right as it rotates on its axis to make a day. So if we look at about the same time each night, we're going to see it sort of like Mars is running in reverse, if that makes sense. Like, again, right now, we look at Mars, we'll probably see Syrtis Major again. And it will be a little bit farther to the left than it was the last time we looked, though. Well, what else? If you might remember a week or so back when we looked at Mars, we could see the terminator, the division between night and day on Mars, over on the right edge of the planet. And as it's coming closer and closer to opposition, that terminator is going away as Mars grows more and more full. On the 13th, when Mars is at opposition, it's opposite the sun in our sky. If you could diagram that out, you'd have the sun, then if you go out in the line, there's the Earth, and then Mars is right on that same line. That's called syzygy, S-Y-Z-Y-G-Y, one of my favorite words, syzygy. That's when three astronomical objects form a straight or nearly straight line in space. Syzygy. What else? As Mars spins on its axis, interestingly, its axial tilt is very similar to Earth's. We're tilted about 23.5 degrees, which causes seasons on Earth, and Mars is tilted 25.2 degrees. So Mars has seasons just like Earth, and right now the southern hemisphere is facing us. It's getting to be summer there in the south of Mars now, and we've watched the south polar cap shrink from session to session as it evaporates during Martian going into summer. I think that's enough. Mark is back.
You told him your favorite word, didn't you?
I did. Syzygy.
Yeah.
S-Y-Z-Y-G-Y, Martian. S-Y-Z-Y-G-Y.
It is a great word.
It's cool. I've often thought of getting a personalized license plate that says S-Y-Z-Y-G-Y. See if anybody can figure it out.
But can you, though?
Can I?
In Colorado, do you have the ability to do that? Does that many carry that many letters?
Sure. It's only 6 letters.
Yeah, I guess you could.
Yeah, they were limited to 6 letters here. They may be up to 7 letters now. Yes, Martian Syzygy. S-Y-Z-Y-G-Y.
Yes, sir.
It's with 3 objects form a straight line in space. Anyway, just a little more from what I was saying earlier. When Mars is in opposition, it is in effect a full Mars looking back at us. We see the lit face 100% lit, and we do not see a terminator to either the right or the left. We did before on the right. That was a sunset line on Mars. And then, that was a sunset line on Mars. After opposition, maybe a week or 2 later, we should see the terminator start showing up on the left side of Mars, on the west side. And then that's the sunset line. We'll see that terminator creep from left to right more and more.
Yep.
And that's when the sun is setting on Mars. I hope I didn't say that backwards.
I don't think so. Okay. Now you can see the telescope is pretty contorted right now. It's actually got itself hanging out there looking at one particular location. And I just got a notification that we got our guide lock, but I am going to bring this up a little bit. I'm trying to find a specific location, and I know what this location is supposed to look like. Let's go this way first.
Martian, we usually see Mars with a terminator. We've been watching it. It's been waxing gibbous, just like waxing gibbous moon does. It's getting bigger night by night as the terminator goes away.
Mm-hmm.
Then it will be full at opposition, and after opposition, it will turn into a waning gibbous Mars. And that's actually how we usually see it, is either waxing or waning in a gibbous phase. That is more than half full.
Exactly.
As Mark said the other night, we never, because Mars is farther out than we are, we never see it as a crescent or even half full. We always see it as gibbous.
That's about the most that we would ever see.
Yeah. It'll get a lot bigger and a lot smaller as it moves away after opposition, but it will always be in a gibbous phase to some degree.
Yep. So I'm showing, I'm in the region of the double cluster. This is not the double cluster. I am just trying to locate Alright, let me do this. Yeah, see, that's the wrong way, I think. Let's do a quick 13 seconds here. Or is Zoe and Daisy here? Yeah, they are. Hey, guys.
Yeah.
Very good. Okay, let me, I just love starry skies. You know, I could just plunder the heavens for hours and just never even look back. Okay, let's go toward the east.
Did you say you lost your position on the telescope?
Yeah, I'm just trying to get it back here. Actually, a good target would be the Andromeda galaxy. That way I'll be able to locate where I am and synchronize. Oh, maybe not. Maybe so. Okay, so we're bringing in... You'll see a star here come in right now. Actually, show you what's going on. Okay, there's a star that's behind here. Where? Right there. And it's gonna auto-center that star. And then race over to the Andromeda galaxy. When they tried to find a double cluster, it couldn't find its high precision point. This is the high precision point. It's a star that is brought into the center before star hopping to the other thing that the telescope does. And now it goes. Knowing where it is, it can actually create. It creates a little database that knows where we're going. Let me just and you see right there in the center is the Andromeda galaxy. Okay, so let's just bring this down and turn off our video preview here. And if I do a let's say 25-second at 16,000 on the Andromeda galaxy, we should have our guide star by now. Takes 11 full seconds. Andromeda. Wahaha. I saw that. Alright, so we're now looking at the Andromeda galaxy momentarily, and you'll see some detail in it, which is really interesting. Okay, let's rotate it to make it a little bigger. Okay, so you can see in the Andromeda galaxy here, this is just a beautiful galaxy. Right through here, you can actually see this dark lane, and it goes up and persists all the way up there. and over the top of the galaxy and through the nucleus of the galaxy here. You see there's dark over here. There's so much detail all throughout the galaxy here. And it really pays to see it, in a processed manner. This is the center of the galaxy. Now, this is this is the center of the galaxy here. Okay, but then down below, down there, you actually see the outer fringe of the galaxy. It goes out beyond this whole frame, and then up there it goes out beyond that whole frame. And the Andromeda Galaxy is just over 2 million light years away, and that means that all the light you see coming from these vast cloud of stars, all of that cloud is not a nebula. Those are stars. They're just so far away that they have a combined light that looks like a soft glow of some kind of like soft item, but they're not. It's actually all separate stars at a vast distance. All these stars you see in the field here all around us, all these stars here, these are all stars in our own galaxy. Okay, so like when you see like this star right here, the Andromeda Galaxy is 2 million light years beyond it. So it's all in the background. This star here, that's over here in our galaxy. The Andromeda Galaxy is 2 million light years behind it. So we've got plenty of separation. Remember, the universe is in 3D. Very hard for people to understand that sometimes. They see stars and they think that, wow, these stars are binary stars. They're right next to each other. They're circling each other in space. We do have those kinds of stars. Albireo in the constellation Cygnus is one of those stars. Mizar and Alcor are stars like that. And of course, other stars are double stars as well, and beyond. Some are quaternary. They're 4 components. Sigma Orionis, for instance, is a star system that has multiple stars in it, and that's near the Horsehead Nebula. But in the case of most of the stars we see here, these are all stars that are all in our galaxy up here. They're not in the Andromeda Galaxy way out there, 2 million light years away. They're all up here, and that's something to keep in mind. There is a separation here. We're seeing it through a veil of stars in our galaxy, all right, like holding up a veil and looking through it and looking at something 100 miles away. Okay, the things on the veil are all the dots you see in this image, all right, and the stuff 100 miles away is the Andromeda Galaxy. It's just a 2 million light years versus 100 miles, in terms of that analogy. So that's pretty cool. But I'm going to drop us down. I'm going to try and bring this to a spot where we can see the other end of the galaxy. And we can actually take some slightly longer ones too. In fact, while we're here, let me take us up to 32,000 ISO. So we're going up several stops photographically. And let's go right to 30 seconds and do that. So this will be a 30-second shot at 32,000 of the Andromeda Galaxy. So to remind you of what we're looking at, here's the Andromeda Galaxy. And we're going to see what we get when we actually increase the sensitivity of the sensor by several stops and increase the exposure by several stops. And you'll see that those somewhat faint, kind of hard to see, dark lanes are going to be a lot clearer. You're going to see this dark lane a lot clearer. And as you can see, we are indeed. Okay.
Is this the new exposure?
This is.
Okay. You could actually see the second dark lane out to the upper right of the center of the galaxy. You could see it before, but you see it better now.
You mean this one?
Yes.
Yeah, we got this one. We got this one. Yeah. We're here's what is interesting about the Andromeda Galaxy. It's actually filling this field of view. And we're seeing a lot of the center of the galaxy, but it goes out like right to about here, maybe a little more, and it fills up, goes way beyond this and way beyond that. So it goes way up there and way down there. It's literally several degrees, and it's several degrees in the sky overall. So that said, the Andromeda Galaxy is a very fascinating location. But let's, as I said before, let's go back and go look at the other end of the galaxy as well. For fun, because we're having fun tonight. We're having fun, Brian.
Donald, you could line up 6 moons or more across the face of Andromeda. Across the galaxy long ways.
So that's about 3 degrees, Donald.
Yeah.
The moon's half a degree, roughly. Okay, so let's do this. Let's actually move ourselves.
Did I say Martian? I meant Donald Gunder.
No, you said Donald.
Oh, okay.
Okay, we got our guide star. Let's do another 30 seconds at 32,000. The music is somewhat appropriate. So for you folks that are watching, what do you have any comment about the audio tonight? Is there a problem with any of the audio? Can everybody hear okay? This is beautiful. Look at that. Look at this. Look at this complexity in this lane here, and over here, and over here. You can see some really nice complexity in this disk, and this is unprocessed. Remember. When we process, it just takes us to a whole new level, you know? Hello, Catherine. How are you? Oh, yes. And Catherine Affinen, I'm not sure how to say that, but I just wanted to let you know. Thanks, Dolly. I want to let you know that the second observatory we're building starting next week, we're breaking, well, we already broke ground. We put a big concrete pad out there for a building in the Sonoran Desert in Arizona, and we will not have light pollution. All we'll have is star pollution. I've been out there and taking photos on the pad. I took photos on the concrete pad, and it's amazing. It's hard, you know. I'm an astronomer, okay? That's what I got a degree in. I would think that I'd look up at the sky and be able to make heads or tails of what I'm seeing. But you know what I saw when I looked up? I saw so many stars I couldn't tell where I was. Literally. No, Hubble's Variable Nebula is wintertime, and we'll see that in the coming months. That's a weird guy. There's so many stars that it was really, really hard to actually focus on what I wanted to take pictures of, because I want to take pictures of all of it. We have an all-sky camera to capture the Milky Way and everything 180 degrees all the way around. And that's going in out there, and I've got the computer. Actually, everything we're using tonight is the Arizona system. It just has to go out to Arizona. Right now we're looking at it. We're doing this all from Connecticut, from our first location. And we have Milky Way, okay, but we also have some light pollution here in Connecticut. And I honestly don't know what I'm going to think when I take that first photo with the telescope out there. Because I will probably say, oh my, I have to re-image every single thing we've ever done. And just to give you an idea of everything we've ever done, I have to show you, and this is, I showed you this before. We are looking, okay, I'm going to show you the background. Here I am in the ship where I have my office. We actually have for you guys, for people that want to give $30 or more to us, we actually have SkyTour LiveStream cards, deck of playing cards, and each card has a different object that we've taken in the observatory. All right, the Ace of Hearts is the Lagoon Nebula, and it says so at the top. And you know, the Ace of Clubs is the Orion Nebula. You know, all taken here. This is, you know, this is just telling you how we're, you know, how we're moving forward for support. You know, it's gonna be great. But man, I'll tell you, a real deck of cards that you can actually play with and use, and it's just the coolest thing in the world. And I got a large playing card company to make these, and they're gonna be made available to you in short order once I figure out the best way to do this. But let me tell you, they're very fun. So that said, it goes without saying that Daryl and Amanda are going to get decks of cards anyway, because they've put in way more time. So they're not going to have to buy any decks of cards or anything. They're going to get them for nothing because of all the time they've put in, and I think they deserve that. But if you don't think they do, let me know. Just say so in the chat and say, nah, nothing for Daryl. Don't give Daryl anything. I'm kidding. I won't listen to you anyway if you said no. So, you have one of our creators too, Daryl, right? I think I 3D printed a creator for you. He's on mute. He'll realize that in a moment.
Sorry. Yes, I did. Typo, if I remember right.
Yeah. Yep. Yeah, so that's cool. All right, so let's like I said, the sky out there, and this goes back to Catherine's comment. The sky out there is just absolutely incredible. I can't get enough of that sky. I really can't. And it's just beautiful, beautiful, beautiful sky. All right, let's see if we can do this again now. Right, so we're heading over to the double cluster. You can hear the telescope moving. Yeah, and now we're lining up, probably with one of the stars of Cassiopeia, which you can't see, but now you can. And that'll be centered up, and that's it. Now off we go. And then the double cluster comes into view. I believe that's it right there. And I just have to bring us up a little bit. It's just such a beautiful cluster. It's just worth seeing. And I'm going to take us down to a better setting. 8,000 for 20 seconds is way more than enough. But here we go. We just reached our 11 seconds. That's definitely it right there. You'll see one cluster here and one cluster here. And they're actually separate from each other in the sky. They're not right next to each other. One's actually closer to us. One's closer to us and one's farther away, which is kind of interesting, you know. And but from our point of view, they look like they're right next to each other, you know. Look at that. There they are. That's the double cluster. Wow.
Nice.
Beautiful, beautiful cluster of stars. And whenever you see a cluster like this of stars, they tend to be young, you know, several 100 million years old to begin with, and maybe a little older in some cases. There are some old clusters. But in terms of the stars within the cluster, you'll notice that there's some stars in the cluster that actually look like they're red. This star is actually red. It's a red star. You can see it right there. Well, that red star is actually not in the cluster per se. as far as I know. Okay, this cluster here, this star right here, okay, is also not in the cluster. It's actually a red star. These are stars that are either in the foreground or beyond and into the background, but I tend to think they're in the foreground because these clusters are each several thousand light years away, and that's pretty good distance. Actually, I don't have to monkey around with that. I should be able to tell you. Yeah, they're like, this one's like 6,700 light years away, and then the other cluster, is just a little bit more than it's 6,781 versus let's see here, versus well, they're giving the same distance here, but they're not the same distance away. Yeah, no, this is stellarium. It's just giving the same distance, but they're not the same distance. I know that for a fact. And the way I know that is because I consulted the database online that actually tells us all those things. There's a database called Sinbad, like Sinbad the Sailor, but S-I-M as in Michael, Simbad, B-A-D. And Sinbad Online basically... is the name of the database you search, and it gives you what's called the parallax values and or the parallax measured in micro arc seconds, and you can actually get the distance to them, and the calculation shows that there's slightly different distances away. And Martian, I said they're thousands of light years away, and these particular stars are they're roughly 7,000 light, just under 7,000 light years away. The clusters, and one's, like I said, a little closer, one's a little farther away. Okay, so it's not like it's directly right next to each other, because they're not right next to each other. But it's just such a beautiful cluster.
They are considered to be physically associated, are they not?
They are, but they're not actually right next to each other. They look like they are. Yes, Sinbad, that's right, Martian. And actually, when you go to Sinbad, there's another one you want to look at. It's called the CDS portal, as in, Charlie, what's it? CDS, Charlie Delta Sierra CDS portal. And that one will show you by name. You put in the name of something you want to see, and it will bring you all that information directly from the actual database that is storing the data for real. It's not like Stellarium, which gives you whatever their particular take on it is. When I'm doing research, I never accept a program like Stellarium. I go right to the root data that's actually the most accurate. And that's the thing that we think is very interesting about this. Okay. So yeah, okay. So you ask about them being gravitationally bound. Not sure if they're gravitationally bound to each other. They're gravitationally bound within themselves right at this moment. Okay. Some of the stars out here may not be gravitationally bound to, say, stars over here. Okay, but there's a central, the mass of the cluster is focused toward the center of mass of the cluster, and that actually is how we notice gravitation works. It's focused at the center of mass. Just imagine all of the gravitational bodies, their gravity summing to, that one place where they actually end up being, centered. The gravitational center. So it's pretty interesting, and I don't know, like I said, I don't know if either one of these are gravitationally bound to each other. I do know that within the clusters they do have that. But isn't this a gorgeous cluster? You can't beat it, It's like a jewel box, isn't it? It's like a jewel box in the heavens. And I'll take a slightly longer exposure I'll go to 12,800, and we'll go to 30 seconds. So we're going to go up 3 full stops so we can get a little bit more of the fainter stars that are in there. Okay, so yeah, Martian, it's actually simbad.u-strasbourg.fr/Simbad. Did you get all that? It's actually fairly simple. Let me just look at that. So you can see how you've got many more stars in here than we saw in the previous shot. So there you can see how this looks like the brightest members, but then you take a slightly deeper photo and look at that. There's even more members of this cluster down here. Look at down here. Okay, look at all these stars right here. Look at all those. Look at 1, 2, 3, 1, 2. You know, these are all in this cluster. Now the thing is, the orange stars are interlopers. They're not part of the cluster, but the young stars are. Okay, and they're all pretty much the same stellar type. Okay, some brighter than others. And one thing that's interesting is when you look at the types of these stars, they, in young clusters like this, they have managed to blow away all the gas in which they formed. In the summer, we've seen the Lagoon Nebula. All right. The Lagoon Nebula is what we call a stellar nursery. In the winter, we see the Orion Nebula, also a stellar nursery. And right near here are other stellar nurseries. We have the Heart Nebula, and we have the Soul Nebula nearby, the Wizard Nebula. These are all stellar nurseries that still have the gas around them, that primordial hydrogen gas, where the stars formed in this material, and they're slowly pushing that gas away with their outward radiative pressure called the stellar wind. We have a solar wind here, they have a stellar wind. And the more hot the star, the more powerful the stellar winds, and they disperse this material so easily. Okay, so let me... Oh, look at that. It just so happens we're right near the Heart Nebula. Let's do that, shall we? Let's go check out the Heart Nebula. You'll watch the double cluster vanish, apparently, but what's really happening is we are just bringing up our guide star. Up here on the left side here, you can see our right ascension, that is our coordinates. You'll see those coordinates change as the telescope moves to different coordinates to find. It's not going to go very far because it's actually zooming in on our nebula right now. And right near us in this nebula is another really interesting feature that I want to show you as well. I think it's here. You know what I'm looking for, Daryl?
The fish head?
No, the fish head's up here. No, I was looking for the Garnet star. I think that's might be confused where it is.
Oh.
Okay. Anyway, let's do this. We're gonna go 30 seconds at 25,600 ISO. We have our guide star right now, and let's go off. Yeah, this is the Heart Nebula that we're looking at right now. Yes, the Garnet star, I think, we should find the Garnet star. Daryl, are you able to just look up where the Garnet star is? I mean,
Yeah, give me a moment.
Is it?
That's Herschel's Garnet star, right?
Yeah, Mu Cephei, I think. Yeah.
Yes, Mu Cephei. Oh, it's not going to be close to where you are. It's
Yeah, I get the wrong place.
no, excuse me. I was thinking Cetus, not.
No. But no, Cepheus is nearby, but Mu Cephei is not near the Heart Nebula, I don't think. But here's the Heart right here. You can see the beginning. You can see it's got a lot of nebulous detail that is starting to become visible. Some up here. This is what we see. You know, now there's a lot of water vapor in the air tonight. In fact, there's already dew forming on the outside of the observatory. But that's okay. I've got a dew system that combats the dew, and I have a dryer system in there that's actually keeping the air around the telescope as dry as possible without generating any heat. It's a passive system. Yeah.
When you have a moment, can you go back to Stellarium and zoom out on Cepheus a bit?
Sure.
I mean, you're in Cepheus now, right?
I believe I am in Cepheus here.
Okay. If you're the Heart Nebula's in Cassiopeia.
Yes.
Herschel's Garnet star is over in Cepheus.
Okay, so we have to just get the coordinates of it. I remember seeing it in here.
If you see Cepheus as the upside down house right now, the peak of the roof is pointing down.
Yeah.
Herschel's Garnet star is up toward the bottom of the house, or actually at the top right now.
Okay.
It's near the base of the house.
All right. So that means that we want to be out here and over here.
Yeah, it's actually not too far from the elephant's trunk.
Yeah. Oh, that's where it was. The elephant's trunk. Yeah, here it is right here. Yeah, there it is. That's probably it. Yeah. Yeah, it might be... Well, we might actually be able to look at that pretty well. So why don't we do that? Let's just go check it out, because it really... if you haven't seen the Garnet star, you're really missing out. Okay? If you haven't seen the Garnet star, you're really missing out. This is just such a beautiful, beautiful sight. You know? And there's a lot to talk about with the Garnet star, and I won't belabor all of it, but I do know that there's so many things about the Garnet star which make it worth looking at. So let's just head over there. We're heading there now. We're on our way. Making our way over. I got to make sure the telescope is going to be able to do it. And I'm looking at... Let me get us... Oh, I think we're going to be... We have a little bit of the dome in the way. It'll find it, okay? So this is the star that it's going to use to line up on. And then from there, it'll get us to Herschel's Garnet star. And we'll actually probably see the star, because it might go back the other way, depending on which star it's actually using to align on. Okay, here we go. And there it is. There is the Garnet star right there. And this star is by far one of the most incredible sights in the night sky. It's a carbon star, which is a star that's extremely low temperature. When we look at it, when we look at the star, you'll notice a couple of things when we actually get a peek at it here. Let me just pop out here and get us. I don't know why There we go.
Are you sure you're on it? According to Stellarium, the scope's pointed a different direction.
Yeah, no, the scope icon on Stellarium is not right. That's another thing. This is the Garnet star right here.
Okay.
I shall prove it. We'll do a 30-second shot at 25,600 right here. May not work. I don't know if the guider... Well, the guider looks like it's probably going to work, but we're going to have a little bit of dome, so it's probably going to have a red haze to it from the light that's on in the observatory, but I can go move the observatory again, because it'll be kind of cool to do that. Now, you might say, why didn't I just motorize the dome? I didn't motorize the dome because I don't want a dome anymore. I want to have just a telescope with a roof that comes off. So this dome is going to be, yeah, see, we got that in the way, but we do have the star there. Actually, it's kind of like it's like looking straight into a laser beam, isn't it? So can I go move the dome?
Sure.
Okay, I'll be right back. And keep in mind that if anyone wants a dome and want to buy a dome, you'll get quite a deal on this one. It nests together if you want to actually create a dome, because I'm going to be getting a building to put this in instead. I'll be right back.
Okay.
And I'll tell you why when I get back.
So, as Mark said, Herschel's Garnet star is a carbon star. It's, I assume, a red giant. It is puffing off its atmosphere, which in this case happens to have a lot of carbon in it, and gives it that characteristic red color. It might actually be putting out molecular carbon, not sure. We don't see any obvious, dust clouds around it or anything, but it's an older star. It's a red star, and it's called Herschel's Garnet star, named after, what's his face, Herschel. I'm having a brain lock here. Can't think of the astronomer's name first. There were 2 or 3 Herschels. There was the guy, there was his sister Carolyn, William Herschel, I think, and his sister Carolyn, and Herschel did a lot of discovery in the sky. I mean, I'm sure I don't know, I doubt he was the first to look at Herschel's Garnet star. He may have written about it first, or somehow, got his name associated with it. William Herschel looked at a lot of stuff, discovered a lot of stuff in the southern sky. Back in the beginning of the Age of Reason, he took a ship down south from Europe, quite a way south. I want to say he was in the southern hemisphere. Might even have gone to Johannesburg or Cape Town, and saw a lot of things in the southern sky that he documented for the first time. Mark is back.
Yes, and this will be a nicer view of it. You'll see momentarily. 30 seconds at 25,600. We're looking at the Garnet star, Herschel star, Mu Cephei. All right, and when it comes up, you'll actually see why it's called that. And now you see. This star is really, really stunning. And it really pays to see it in the right light. So what I'm going to do, and this will actually test my auto-focusing system. When I'm going to go to the pass-through where it's just a straight pass-through. And as it does so, okay, here it is. Now we should refocus everything. And I'm not sure if it did. I'll just do a quick shot just to see. If it didn't, then it's no big deal. But it's a test. It's a testing thing I'm doing anyway. So 15 seconds here, just to get a shot. I think it's gonna be slightly out of focus.
Slightly out of focus might actually help it with the color.
Yeah, that's right. Well, not so bad. But that's that is the actual color of the Garnet star. Look at it compared to the surrounding area. It stands out, man. It stands out. Hey there, Eretz Zero. How are you? Catherine, I'm actually in my office, okay, and so you can see kind of where I am. This is my office back here, all right, and you'll see portholes up there. This is my office is actually made up to look like an old ship because I do a lot of work for the Navy, and many times Navy guys will come pick up stuff and they'll hang out here because it's sort of cool. It's more like a movie set in a sense because I work in the movie and TV industry as well, doing visual and special effects, and so as a side product of that, I do a lot of work for the Navy. But I'm going to be doing more astronomy because that was what I got my degree in, and astronomy is my thing. So I'm going to be doing a lot more of that, as I have been for many years now. So it's good, you know. But that's a good question, you know. So anyway, so yeah, so this is a neat view of the yeah, see, they are slightly out of focus. Yeah, so it's not quite focusing right, but don't worry, I'm gonna have it all figured out. We'll get it figured out. So now I'm gonna go back to filter number 2, narrowband number 2, and I will have to focus it now just to see. Well, I'll just take a short photo just to see how bad it is. Hey, Gas Mask, how are you? Hey, Daniel Berger, how are you? Welcome to SkyTour LiveStream. Yeah, so you can see that it's actually pretty well focused here. It did refocus on this pretty nicely. That's not bad. So there it is. That's Herschel's Garnet star. And the color is slightly purple because of the fact that it doesn't have the filter's not clear. When you have nothing in between you and the filter, okay, in the sky rather, then you see this, and this kind of brownish gray glow. That's the sky glow. A little bit of the light pollution that's here. It doesn't really show up when you look at it until you actually do a deep exposure, long exposure. But when the filter goes on, it becomes much sharper and clearer, and this is really quite lovely. Yes, Gas Mask, that was a good movie, Greyhound. I saw that with Tom Hanks. Good movie. Yeah, a lot of fun to watch that movie. So, now that we've done that, we might as well, since we're in the neighborhood, we might as well just move a little bit to the west and check out the elephant's trunk before we run to Mars. Mars is getting higher in the sky. It's looking better. I was just looking at it. So we're going to go and head to look at the rest of the elephant's trunk. Goodbye, Garnet Star. Thanks for coming. We'll be back. And I'm actually going to take us up a little bit too. And I know okay, we're going to see if this is a good location. When we get to the elephant's trunk, we get into here, and some of these objects, they just show up so brilliantly. They're beautiful. And I did actually do a high-resolution shot of the elephant's trunk earlier. I think yesterday. I did a private research night for myself to grab some imagery, and I will show you the elephant's trunk after processing, because that's probably the best way to look at it. Let me see if this is... Yeah, this is the one. Okay, so I'll be to that one in just a minute. So let me just first take a shot here to see if we can get the elephant's trunk out there for you. We'll do 25 seconds at 25,600. I want to see how far or how close I am from the elephant's trunk. So I put the Garnet star way out to the view, and we're kind of like here. So if we do this, this is our field. Oh, well, I think we're probably looking at only probably like this right here. Oh, maybe this way. I might have... Oh, the telescope's upside down, that's why. Okay, so this may not have done it for us, so that's okay. I will actually have us go find it. Alright, let's see what we got. You know, we're only partially there. No problem. I will now take us there directly. Alright, elephant's trunk, off we go. And now the telescope is going to take us to a star to guide us over to it. And there's our star that's taking us, that will take us there. Yeah, gas mask. The International Star Registry doesn't have any power to give you a name of a star. The International Astronomical Union comes up with all the names. The IAU, they don't have... Daryl's kind of right. It's a fraud, but it's actually... It's within legal limits, so it's not technically a fraud per se.
Well, it's...
They're operating legally, but, you know, fringy.
It's meant to separate people from their money. And this is the problem I have with it. They prey upon people who want to commemorate lost loved ones, in large part. A lot of people, they hear about it and they think, golly, you know, let's commemorate dear old granddad. Let's name a star after him.
Yep.
And, hey, they'll happily name a star after granddad, but, you know, it has no legal meaning. They just charge you money for it. And they don't like it when we say that, but it's the truth.
That's right. That's true. Okay, 30 seconds at I'm going to go a higher sensitivity here. We're going to go to, let's do 40,000, just for fun. Okay, so I should have my guide star by now. We'll go 30 seconds. Hey, gas mask, I own a piece of the moon now. Don't you be going there. Just kidding, I don't. But yes. Honestly, I said a long time ago, once we start going to the moon, the next people that go to the moon will be the real estate agents. They will. Okay, so I recognize these, the two stars that are in this field of view over here. These are the stars right with the elephant's trunk, and the elephant's trunk is visible. You see this dark area right here with red fringing? So that's I take a bunch of these raw shots, okay, and I turn them into a finished view, and I'm going to show you that finished view now. Look at that. That, believe it or not, was this. From these, I get the information, and look at that. That's the elephant's trunk. Look at it. You can see all the detail, nebula. it's a dark nebula, so it's actually kind of hard to see. It's hard to find. There it is.
Is that the picture you shared with me yesterday, Mark?
It is, and
yeah, that's very impressive.
It is a beautiful nebula, yeah. And so you can see a lot of detail. What I really like about it is this little hole here, and you can see something going on in there. That's actually these stars. If those stars are in there, they could be responsible for this hole, which is actually their radiation blowing this material away. But that's it. That's how it looks, you know. And then we come back, and you know, you can see the nebula just barely, but it's really got all of this information buried in it right there. I think that's just so cool. David Schmidt, how's it going over in Thailand?
Hello, David Schmidt.
David Schmidt's in the house. Nice to see you, David. Yeah, it is just incredible. So yeah, also the other night, last night I took photos of, and this I did because of, I think Isabella Melamed, who is a frequenter of SkyTour LiveStream, had asked to see the Bubble Nebula at one point, I believe. And I took a photo of the bubble for her yesterday so she could see it. And it is, I'll show that right now, actually, because it looked pretty interesting last night. So this is the bubble. I'll show you. Here we go. The Bubble Nebula is somewhat nearby, but this is what the bubble looks like. Look at that, huh?
That's really cool too.
Yeah, and just so people understand, some of these photos, I actually have the ability to upscale them so they could actually be billboard size, believe it or not. And it would take a huge amount of space to do that, but I could actually put these up the size of a billboard. These are just, you know, beautiful. So this is
out of paper and ink too.
yeah. This particular nebula, usually we didn't get more than this typically, but with the filters I'm able to grab all this additional detail that we never could see before. The early shots of the bubble, well, I'll give you an approximation. The early shots of the bubble kind of look more like, let's see, that we took were kind of more like this. Kind of like that. All right. But we were able to make a huge number of leaps and bound changes with the new filters, and now we can capture all this additional data. Plus, look at all the stuff out here. Look at all this nebulous detail out here. Absolutely amazing. Yeah, really cool. Anahata's here. Hey, Anahata. That's Bonnie. Hi, Bonnie. Yeah, so anyway, that's what we looked at with the other night, and I did this as I want to do a private research thing, so I did that, and it was a good thing I did because there was a lot of things that I wanted to see, and not bore you with the many photographs of the same thing I took over and over, because that's what you have to do, right?
You showed me every one of them the other night.
I did, didn't I?
Oh, it's quite a change from the earlier ones I'd seen.
Yeah, well, I'm using. I didn't share this with anybody yet, but I used a special software that I got a hold of. It uses AI, artificial intelligence, to go through and iterate through your photos to get rid of all the noise. Now, I use a camera that can produce a lot of noise. For example, this 30-second photo I just took. Okay. All right, there's a lot of noise in this image, and if you want to see it, all you do is zoom in. That's a star right there. Okay, well, look at all the noise around it. How do you know what's star and what's not, you know? Well, the software has the ability to go through and figure that out. And it knows how to figure that this stuff is red nebula, you know, red diffuse nebula, and not actually noise. And so it can fix that. And so that was a really, really nice acquisition to add that software to my arsenal. Now I use Photoshop and I use these other packages, and I found out that you can't get just one package to do all of it. Photoshop can do bits of everything, but it can't do all of it. Okay, and unfortunately that's the case. But you know what? It's all right. It's okay. Now what I'm going to do is, if anyone has any questions, by the way, go ahead and put them in. And if I don't see him, Daryl may see him. And Daryl, if there's questions, make sure you just interrupt me and say the question so we can actually. If you're going to answer it, go ahead and answer it, but just read it back so people can hear it that are not in the chat.
Yeah,
makes it nicer for everybody. Let's see.
Will you excuse me for a moment, first, please?
Of course.
Thank you. Be right back.
All right. So while he is heading off to do whatever he's doing, I want to show you another nebula right here. Okay. This square is the telescope's field of view, a computed field of view based on parameters I've given it. I've given it parameters for my scope, and it puts this up there. Now, before we're going to go here, and I'm going to we're going to come to the Wizard Nebula here. So off we go. So we're on our way. You'll see the stars zip away over here as we head off to it. Now, just so you guys know, those of you that have been with me know this, but just give you a quick overview. This is the telescope control system up here. This is me down here. Hi there. Daryl isn't on camera at the moment. And this is the camera control system, and then the view into the telescope observatory down here on the lower right. This is the live view everywhere else. And we're looking here, and it's going to center up the star, and we're doing this high precision pointing, and then boom, once we line up, off we go. And we're going over to this place called the Wizard Nebula. And then what we have in addition is this planetarium view that we look at. I will get rid of the observatory view for now. This is capable of controlling the telescope as well, and that's what I've been doing. And we are right on the Wizard Nebula right here. And I will go out and take a photo. So we'll say 30 seconds at 40,000. And what I have to do is, after the telescope finds the location, then it's identifying a guide star in the field, and it has there's actually two more telescopes mounted on the main scope, and one of them is a finder, and one of them is used to track using a star tracker that's built in. And now that we have a guide star, it takes 11 seconds exactly to get a guide star each and every time. And after the guide star is grabbed, we go off and take the picture. And it's under guide, so we'll have no problem. We'll see it. And okay, that was not it. That was actually something else. So we're still waiting for the Wizard Nebula. It'll be here momentarily. And there it is. Okay. Here's the Wizard Nebula right there. You can see it. Now, the Wizard Nebula is a beautiful nebula. It's what's called a diffuse nebula, and it's also a place where stars are being formed, as we speak. And so it's really quite an amazing location as well. So let me see if I can. Let me just bring something up here for you. Okay, I think this is the one. Okay, so in order to see what that looks like when you do processing on it, here is the processed Wizard Nebula. Okay, you see that? So we actually see that this is the view as captured by the telescope. And now you can see all of the data in here. You can see, like I was looking at before, you can see all the many little tiny red clouds, a lot of red clouds here. Okay, and then in that one shot though, you also see all the rest of the data here, and there is the Wizard Nebula in its full glory, and it's really, really pretty. Again, this is another shot that has been AI modified and iterated through to get rid of all the rest of the noise. We can actually zoom in on this here, and you can start to see the noise only when you zoom way, way in. And are you ready for this? I can get rid of that too. I've found ways to do that and get rid of it. But that's what happens when you have something that is this pretty. It's just a beautiful, beautiful image, and a beautiful nebula. But again, this is the cluster that formed in the Wizard Nebula. There's a line of them here along a shock front, which is interesting. That shock front is probably along this direction from the cluster, pushing gas, and they've probably caused stars here to form as well. It's a strong possibility. So this gives you an idea of how the finished imagery will look. Again, this is to begin with. All right. Right there are those two stars and that one star up there, then the nebula right here. And then when we go look again, well, we have that star, those two stars, and the nebula. So that is how it comes to fruition. And these images will be up on SkyTour LiveStream's Facebook site for you. And I'm trying to get them all up on astroimaginglive.com, where SkyTour LiveStream is up there, Bill New York Skywatcher is up there, and P&K Space Imaging is up there. The three of us all stream, and we all do different things. Paul and Keith do the moon and the planets. Bill does the meteors and the wide field views, and we do the deep sky like this. So we don't step on each other, but we really enjoy doing this. Yep.
Back, by the way.
Yeah, I heard. Thanks.
Mark, I think Martian is curious about obtaining a high-res file for a couple of the objects.
Sure. What would you like, Martian? They're all free. We don't charge.
The Bubble Nebula and the double cluster.
Yeah. Oh, Isabella's with us, isn't she?
She is.
I think I saw Isabella out here, didn't I? I have to show her the processed bubble that I don't know if she got to see it. If you just joined us, Isabella, I wanted to just show you the other night. This was the other night. Literally just the other night. Not that one. It's got to be this one. Yeah, this is the one. Okay. This is the bubble, Isabella, from the other night. So this one... Now, I used to have to say that the resolution is only a certain amount, okay? But you know what? That's no longer the case. I can up-res these now to between twice, 4, 6, 8 times bigger. But just a word of warning, this file right here that we're looking at, the bubble, 6 times bigger becomes a 92 meg file. So if you want it, I have to do it in like a Dropbox thing so that you can get it, because I can't email these like that. So this is the bubble that I believe you, Isabella, wanted to see that one night. But this is from last night. It was exceptionally clear. Look at it. Oh, it's just stunning. It's just stunning. You know, and it keeps on giving. And, you know, like I said, you know, when we look at the bubble nebula, we're looking primarily at this section, but we actually see, for the first time, actually, the complete bubble here. And you'll notice how there's some extra stuff sticking out here. The star in the middle was pushing out this material, that should say, pushing out radiation. And it's a well-known, very hot type star, and it actually formed this bubble of expanding gas around it. And the bubble is not perfect, okay, because you can see how it's been stopped here, and it's caused like some bunching up over here. That's because of the different densities of the material that this gas is hitting in the interstellar medium as it expands. It is just beautiful. Yeah, Isabella, send me a link. My email address I will put in here. If anyone has any questions, you guys can contact me directly. Okay, anyone that's in my streams can contact me. Okay, so this is me, MUFONanalyst@gmail.com. Yeah, I also have some big news coming up that I can't yet mention, but I've got an opportunity that's going to be could be right around the corner, that's just going to change everything for us. So I'm hoping that'll work. 600 DPI, Terry, that's what you're saying? Is that Martian? Oh, I know. Deep sky is really intriguing, because when we're looking at, for instance, in the bubble nebula here, we're looking at a place where we could never survive. The fact that this gas is caused to glow by hot ultraviolet energy from the star in here is really a death sentence for us. But once this star goes supernova, or once this star dies in other ways, it's very possible that this area will then cool down, and then planets will form, and solar systems, star systems will form. And then the planets could eventually hold life. This is what happened here, very similarly. Now, we are no longer in the same cluster that we were in when we formed. We were formed in a cluster. And on Sunday nights, you can hear our show, SkyTour Radio, and that's on KGRAradio.com. All right, that's KGRAradio.com, the same place as Carol Carl's show, which is Friday nights at 7, called Behind the Obsidian Curtain. And SkyTour Radio on Sunday nights takes us through the formation of objects like this. We talk about the deep sky. We talk about astronomy. We talk about findings. This Sunday, we're going to be talking about some really cool findings. We'll be talking about the phosphenes in Venus' atmosphere, which could indicate potential life in Venus, of all places. And, you know, Ian Malcolm, the character played by Jeff Goldblum in Jurassic Park, you know, he said it best. You know, when they said, you know, that life can't replicate, can't reproduce on the Isla Nublar, which is the dinosaur island there, Jeff Goldblum kind of took issue with that and said, well, life finds a way. And so maybe that's what we're talking about. You know, life could find a way. So maybe we'll find some life in the most in unexpected places, right here in our own solar system. So keep in mind that if you join us on Sunday nights, 8 to 10, you'll get to hear more about this type of stuff. Also, keep in mind that all our streams, we do this kind of stuff. We show you everything, live and uncut, because there is no cutting, right, when you're live. And that said, we are, a good tight-knit group here, Daryl is part of our SkyTour Radio now, and we had to drag you kicking and screaming, Daryl, to get you to come on board, didn't we?
You did.
He wasn't sure he wanted to do it, and I understand. It's a commitment, and I could never and would never force anyone. That's their choice. But Daryl has become an invaluable addition to the show, and SkyTour Radio wouldn't be the same without him, and SkyTour LiveStream isn't the same without Daryl either for me, and I wish Amanda could have joined us tonight, because then we could say the gang is all here, because Amanda and I and Daryl are on SkyTour Radio and SkyTour LiveStream. But I guess we just have to roll with it as we get it. Not everybody has a life, and they're busy. I have a life. I'm busy. I work for the Navy a lot of times during the day. I've got a project board over here that you can't see. It's a whiteboard with about 10 projects on it. And then I'm working on a movie with Douglas Trumbull, who, of course, is the famous visual effects guy. He did Close Encounters of the Third Kind, Blade Runner. Doug and I talked several times today and yesterday because we're building some really cool visual effects models for a movie about Nikola Tesla that we're doing. And it's a really phenomenal stuff, when you work with someone of that level of genius. And he's funny. He jokes around about himself. Like when I talk to him, I say, I'm not worthy. He goes, yes, I know. He goes, I'm a god, I know. And of course, he's kidding. He's very, very self-deprecating. Anyway, so what I need to know, first of all, here is who wants copies at higher resolution and of what. And then we could work from there. So you got my email now. Okay, and just send me a message and we'll go back and forth until we figure out what you want. It's Martian, they'll be big, but you know what? You'll be able to blow them up somewhat bigger. And I have a way, like I said, I can up-res them. Again, I use an AI process, artificial intelligence, that will go through and iterate on the data and make it larger and larger without ruining it. So I think that you will like the results. Hey, Papa Tom. Welcome. So let's go see now. Did I waste enough time before we get to Mars now? I think it's about time I get to Mars, huh? Daryl will say yes. Daryl says yes.
I'm sorry. Absolutely.
All right. I'm going to try for this little cluster. I'm sorry, not cluster. I'm going to try for this tiny little planetary nebula first. And then we'll go check it out. Let's bring our star in. This is our guide star. We're using the same one we saw before. And we're going to be right on the edge a little bit, but maybe we'll come back. If the star goes back the same direction when it races away, then we won't be touching the dome. Oh, the anticipation is killing me. All right, so we're going to be moving back out into the dome opening and we are. All right, so now we're going to be moving to a small planetary nebula. It's fun having a telescope, guys, because then, you have the ability to peer into the cosmos and to see things that your eyes can't see and to explore and experience sights that you could never hope to see. That's what SkyTour LiveStream's all about. That's why I started this. You know, when I started my astronomy career, I was working in a parallax program where I was studying nearby stars, you know, and doing lots and lots of program stars. That was part of the process. And then I studied stars that were moving very, very fast out of our galaxy, speeding out of our galaxy, and I identified a number of them. And it was all good. It was all a lot of fun, really relaxing and enjoyable. But you know something? I thought, how can I share all this with people? I began to realize that I want to be sharing this. I want to be able to bring this to people. So this is how I'm doing it. This is it, man. You know, we got this real quite fancy setup that we're using in 2 places. We're going to have a second observatory in Arizona, which I mentioned earlier in the stream, is being built next week. I was supposed to be there. Actually, I would have just gotten back from there. But again, COVID kept me away, you know, with the restrictions. And I'm just going to drop this down, and we'll do 30 seconds at 25,600. It's going to be way too bright, but let's see the star field as it's in. But so it's going to get built. I got a contractor out there, and Marianne Robb, who is in the chat a lot, is the person who is managing most of that. And she's so committed to SkyTour LiveStream West, this is East, that she actually got a license plate, STLSW. And I told her that she's earned that license plate. You know, I don't need a license plate. She's earned it. She's really earned it. Well, look at that. Dead center. Look at that. Holy cow. Well, it turns out we did need that exposure of that length because this is a very faint planetary nebula. Look at that. Wow. That's actually quite pretty. You know? We've looked at this before, Daryl, and we actually couldn't see it. And it was because I didn't realize that I had to take a longer exposure. And it's quite faint. But look at that field. Look at that field of stars. Look at that. And in there is a star that has died. Now, I got a question for you guys. When you look at something like this, and you know that that's where a star died, and when you know that our sun is going to probably generate one of those someday, because it's around the same mass, do you ever wonder whether there was an alien civilization around that star that maybe didn't survive it? Because this planetary nebula, the star, died before they could get away from their star. It would have killed them. It would have killed the entire planet. So I think that's pretty amazing. And it's also a poignant thing. And this particular planetary is kind of cool because it looks like it's framed in the stars here. These stars seem to frame it like it's holding it in its hand. It's kind of cool. Sort of like, I don't know, cosmic marbles or something like that. Anyway, that's a real beautiful little planetary nebula that's hiding out there in the middle of nowhere. So it's something else that's really beautiful. And just so you know, that little planetary is over 5,500 light years away. So when we look at this, we're seeing it as it was 5,500 years ago, because that's how long it took for the light to get here. Yeah. That's right. Martian's right. Martian, I'm really enjoying how much you're getting into this. It's really cool. I know a lot of you were very much into it, and you know you wouldn't be here if you weren't. So I really appreciate that very much. Appreciate all of you. You know, we have there's 30 something, 37 of you watching right now, and we're having a good time. So what I'm going to do is I'm going to get ready for the big event here. Now that Mars is probably higher in the sky enough so that we can view it. Is there anything else that we want to see on the way? Well, yeah, of course. There's plenty to see on the way. But either way, I'm going to have to move the telescope. I'm sorry, move the dome to get there. So what I'll do, maybe I'm just looking at the heart. That was showing, so that might work. Well, on the way, let's see if we can look at the Soul Nebula. All right, and then I'm going to go for Mars after. So we're going to head to the Soul, look for our guide star to come in here momentarily. Okay, we should be getting to our guide star. Oh, let's see. Right about now. Yeah, there it is. Okay, let me bring that in for you. You can see it down here by the dome cam. You can see the telescope is really canted over in there. It's actually heading right towards the edge of the dome. This is the reason why I'm going to get rid of that dome and just get a building where the roof rolls off. I don't need a dome anymore. I thought it was really cool. It is. I helped the company develop this product a little better. I gave them some suggestions as an actual user. But the dome has outlived its welcome because I'm doing everything remotely. And I don't want a motor to open the dome. I don't want a motor to move the dome back and forth. They have them, but they're problematic right now. But if you're going to be in the dome, it's a great thing to have. It's excellent. But if you're not going to be in the dome, like I'm not, then it becomes a problem. So, like I said, it'll be for sale when we get it. There. Once the telescope that you're looking at right here in this dome is out in Arizona, I have another telescope right behind me to replace it. And we'll be putting that one in there. But before we do that, we're going to be putting a building up that's going to actually be a little bit more like the Arizona facility. It's going to have a roll-off roof, like I said, all computer controlled the same way. And I'll just make another circuit to do all the same stuff. So I'm pretty excited about it, you know. Real easy to do it. Hey there, Dr. Fox. How you doing? Thanks for showing up tonight and hanging out with us. Okay, so now we are here. Let's do, again, where we are is at the Soul Nebula. We're going to just try and see if we can capture some of the soul. That didn't sound so good, did it, Daryl? Capture some of the soul.
Kind of thing, if you're going to capture any, I think you'd want to capture all of it.
Yeah, right. That's right. Yep. Like in Supernatural, one of Amanda's favorite shows. Okay. Oh, look at that. It's there, but it's really kind of subdued a little bit, but you can see it. It is here. There it is right there. Let me bring it up larger for you guys. Okay, you can see the nebula is here and down here, comes down through here. This is the central cluster in the nebula right there. But that's the Soul Nebula. And you can see it comes over here. I could turn this into a beautiful image just like the other one, but I would have to take a lot of images and then stack them together. And I think that's very important to do that. Okay, so I won't do it tonight though. But I figured since we're on our way toward Mars, we might just check it out, right? And we're right at the limit where I'll probably have to move the dome now to go to the next location. And it's alright. Daryl, would I be able to impose upon you again to entertain these amazing people?
Sure.
Right. All right, folks, I'll be right back. I am going to move the dome to Mars. Be right back.
Okay, yet again, we're moving to Mars. It was cloudy here today, and I was really kicking myself. I went to set up the 5-inch Maxitov scope last night for a quick look, and I couldn't find the screw that attaches the scope to the tripod. And so I packed everything back up. It was hazy yesterday and some smoke from the forest fire still, but later in the evening it was pretty good, but I couldn't find that darn screw. So I put everything back away again and went to bed, and actually right before I went to bed I found it. When I picked up the tripod, it fell out and landed on the floor. It was right in front of me the whole time. Anyway, today it was cloudy much of the day, and cloudy at sunset, which made for a pretty sunset, but it didn't look promising for looking at the sky tonight. So I find myself here, and when I was away a little while ago, I took a quick peek outside, and hey presto, after the sun went down, the clouds went away. It actually looks pretty nice out there right now, so I'm kicking myself yet again. I might try dragging the Maxitov out tonight after the stream. Who knows? We'll see. I've been going to bed pretty early lately, but I need to take advantage of Mars while it's prime time. And again, Mars is close to opposition now. It'll be at opposition on the 13th. That's when it will be 180 degrees from the sun in our sky, just like a full moon. A full moon, by definition, is at opposition, and Mars will be too. It'll be a full Mars, 180 degrees from the sun in the sky. When the sun sets, Mars will rise, and it will traverse the local overhead meridian at midnight, local midnight, which is probably about 1 in the morning from wherever you are with daylight savings time, and it'll set at sunrise. And because we have been lucky enough to have Syrtis Major facing us here lately, because of that 24-hour, 37-minute rotation on Mars, we see Syrtis Major night after night, but advanced a little bit, or retarded a little bit to the west. If we wanted to see the far side of Mars, what's in the dark right now, you'd have to get up early and look before sunrise. I've seen some Mars pictures very recently that did exactly that. The guy was waiting until like 3 o'clock in the morning to take a picture, and we could see the side that faces away from Syrtis Major. Anyway, Mars is back.
No, Mark is back, but Mars is coming.
Excuse me. Mark and Mars are both back. And Martian's here too, so
That's right.
My Uncle the Martian, or what it was called. My favorite Martian. There you go.
That's right.
My favorite Martians.
Yeah. Who played it was tip of my tongue, the name of the guy.
Ray Walston.
Ray Walston, there you go. Okay.
He also played Popeye's father in the Robin Williams movie.
Whoa, unhands me goyle. Ugh.
That's Popeye. And there's Mars.
Oh, it's looking like a big red disc.
All right. Mars.
I love the old Popeye cartoons.
I know.
I'm strong to the finish because I eat with finish. I'm Popeye the Sailor Man. Boop boop.
The really old ones, they're very trippy. I always
are.
wondered if somebody wasn't smoking something when they made those. Some of them,
He's always talking to himself in the old ones.
Like,
Yeah.
He's always like mumbling to himself.
They did some in full color too, way back when, that are quite long. They're almost like little mini movies, and TBS used to show those late at night, a long time ago.
They're all black and whites.
Some of them were color, unless they were colorized. Some of them were very lush color, and they were just so trippy. They had the Jeeps were on there, I think.
Jeep.
Eugene the Magical.
It's Eugene, the magical Jeep. Ugh.
They were they were like 45 minutes long though, and they were really trippy little, you know, almost more than cartoons.
Yeah. Okay, we're dropping down now to get Mars down to an exposure. You'll notice, guys, that we dropped the ISO down to 50, and the exposure is a 1/25th of a second. This we can do because Mars is so bright. Let's just take a picture and see what we get.
Keeping my fingers crossed for good seeing.
Oh, I think our wish has been granted. Look at that.
I think you're right.
Look at that, guys. Wow.
Well, that's Syrtis Major, just
right
a little above center, above and to the left of center. It looks sort of like an upside-down Africa in this picture.
Yep. And then this goes down to Terrana and Hesperia, I believe. And we got Hellas Planitia.
Samaria. That's where Conan was from. What's farther to the lower right?
Down here.
Yeah.
And we have Hellas Planitia is right about here, I believe.
Uh-huh.
Yeah, this is nice, guys. This is a really nice night. We got some really good seeing. And to be honest, there's a lot of moisture in the air, so I'm kind of surprised that it's as good as it is. And let me just give you the full benefit rather than having to see it really small like that. That's really pretty. Not bad, Daryl. Not bad.
Yeah.
Yep. The autofocus is working too, which is kind of cool. So let's, and this is, as far as the filter, this is narrowband 2. Let's drop down to narrowband 1. All right. And you'll notice how the image almost vanishes because, again, narrowband 1 is the tiny slots through the spectrum. And every one of those slots is a vital location that we want to see as astronomers. So let's go up about 4 to 6 stops, and then we'll be able to take another picture. And Mars won't look the normal color that it should look. That's correct. But look what it does look like. Interesting. Wow. Not bad. It's looking pretty nice, Daryl.
Mm-hmm.
Pretty nice. Wow. I did take 40 seconds of video the other night, and I did stack it using, I used PIPP to separate the good from the bad frames, and then I used Registacks to actually put it all together for those that know. And unfortunately, again, Mars is this big in on my screen in this telescope, so we couldn't really see too much detail. So that's why we're not what we'd call the planetary specialists that Paul and Keith could be. But look at that's really pretty, man. That looks really gorgeous. I'm not sure whether I like this view more than this view.
I liked that one.
This one is pretty because it looks more red. But you can actually see, notice how this area of the planet is, you can see this more distinctly, right? With the other filter, this becomes a little bit more hazy, but there are some details that stand out, you know, so each filter is offering its own specialties, right? So let's go back to this guy and let's increase this. Let's go to 1/3 of a second here. Okay. And then we'll drop it way down now. Okay, to 1/8 of a second. Let's see what that looks like. Oh, I don't know. Now see, when you look at this, okay, you can almost imagine seeing like a bunch of lines. Okay, that's not how this really looks, but through a telescope, when that's all you've got, then you might see this. Now, Schiaparelli would have seen what looked like these canals. But he wasn't thinking that they were canals per se. He was thinking of them as features, but I think it was somebody else that called them canals, like water irrigation type canals.
Yeah, well, in Italian, canali means channels.
Yeah.
And Percival Lowell, the rich guy, he took a great fancy to Mars and built Flagstaff or Lowell Observatory down in Flagstaff, Arizona. It's still there to this day.
It is.
He put a great big, very expensive, huge refractor telescope in it, and he made Mars his subject of study. And he interpreted Schiaparelli's canali as canals.
Yep. And that started a fervor.
With a fervor, yeah. And Lowell drew some very fanciful maps of Mars that were absolutely covered with canals.
Yeah, a lot of linear straight features. But you know what? If you're thinking you see them, then you see them in your mind, and you will draw them. All it would have taken was for him to be able to take one nice photograph of Mars. And he would have seen that, no, these are just dark features. But he didn't get a chance to do that. But look at that detail. That's beautiful. Time for another shot. Actually, let's go back to the other filter. So let's go to narrowband number 2. It'll be a little too bright, so we have to drop it down now to another 30th of a second or so. And we'll take that photo and see what it looks like. Oh, that's interesting. Look at that. That looks pretty cool. I mean, just to make sure that's not an artifact, let's go down to a 50th of a second. No, let's go to a 60th of a second. Take that photo.
What's not an artifact?
I'll show you. So here's the image, right?
Okay.
Look how sharply defined this is.
Yes.
Okay.
I think that's real.
Yeah, it could be, because it still looks pretty sharply defined here. You know, that's actually a really interesting image. Wow.
There's a little dark spot down almost at 6 o'clock, a little above the planet's limb.
This here, or is it this one?
To that right there.
Okay.
Yeah. I have seen it in several of the exposures you've taken tonight. I looked at the map, though, but that's one area they do not label. They do show it as a darker patch, but they don't have a name on it.
Okay. That's just an oversight, because everything on Mars has a name.
Yep.
Okay, let me go back and bring us back to 30th of a second here and check this out again. Wow. That's actually pretty good, guys. You know, this is not bad. I'm still on the fence whether I like this view or whether I like the other filter view. Yep. I think I may like this filter view better. And this here, we're going to do like, I'll try a 1/6 of a second. I didn't do that before. Yeah, look at that. That's showing a lot more detail, actually.
You think? I think number 2's a little crisper. Of course, you're doing a longer exposure there, and
well, we can do that. Let's actually. Yeah, you're right, and the longer exposures tend to.
I mean, that'll be
muddy the
seeing,
water.
but upsets that.
Yeah. Yeah, Martian's got some planetary geology knowledge here, I see. Yeah, there's under the south pole of Mars. Actually, we talked about this on SkyTour Radio as well, and I did some research on it. there has been there was a radar study done from orbit, and it showed that there was standing water underneath the Mars south polar cap, several kilometers long. And the question becomes, and the one that NASA is weighing heavily, is it possible that life has sought a foothold in this underwater lake? Why would we even consider that? Why would we even think that's a possibility? Well, the answer has to do with looking at Earth, and especially looking in Antarctica. Because down in Antarctica, there's a place on Antarctica where 2 miles beneath the ice is a lake. It's called Lake Vostok. Vostok with a V as in victory. Lake Vostok is a location where a water lake, liquid water lake, was thought to be isolated for millions of years from the surface. So they were thinking, well, what could possibly have survived down there? And they actually drilled down to the lake from the surface. And what they found was probably the most astonishing find of science in the last, I'd say, century. They found over 3,500 species of different types of life down there. Now, this isolated lake had literally created its own life cycles, and water cycle, and carbon dioxide cycle, and oxygen cycle. And all this material was being formed and interacted through geology of the lake. And you could see how material was being brought down to the sediments of the lake and then making its way, percolating up into the water again. An endless life cycle. Long after humans are gone from this planet, there will likely be life in Lake Vostok. So I think that's really interesting to think about, because long after the oceans on Mars left, and yes, there were signs of a mega tsunamis on Mars. You're absolutely right. I think that was Martian who said that again. Long after those tsunamis and long after the water disappeared on Mars, the lake persisted and is still there to this day. And that's the location that we really need to be at. Now, why do we have liquid water down there underneath the Martian polar cap? It's a south polar cap. Actually, it's under here. This is the region of the south polar cap right there. That's where it is. And why is it that there's even liquid water there? The pressure on the Martian surface is 6 millibars. Okay, actually 6 millibars versus over 1,000 millibars here. So it's very, very small. Okay, so that said, we look at how thin the air is there, and it's only carbon dioxide there actually, and that thinness of the air is something that you would think would cause there to be very low pressure at the surface of Mars, and that's true. And you would think that with the thinness of the atmosphere, that the ultraviolet radiation can get to the surface and literally disassemble water molecules, and that's true. So how is it that a lake can survive on Mars? The only way it could survive is if it was underground. Underground, the weight of the sediments on top can press down on the water body pocket and could cause that water to be in liquid form. It might be very highly saline or not. Most likely it is. But either way, we know from looking at Earth that, the sodium and chlorine atoms that combine to form salt, NaCl, well, we could have different types of salts as well, and we do. But we could also have different types of salts on Mars. And maybe there's life there. Maybe there's life under this south polar cap. It might be microbial life. But think about it. That is probably going to be the next major find, is life in our solar system. And the life underneath that south polar cap isn't going to operate by sunlight. It's not going to see sunlight. It can't. There's no sunlight to be had that far down. It's going to be cold and inhospitable and perpetually dark. So what kind of processes will they actually be able to use? If it's not photosynthesis, which is what much of the life here on this planet is, what would it be? Well, we didn't know what to look for until we realized that life on this planet in those similar type regions, like the deep ocean, survive using different means, create energy for their forms through different means. And that different means isn't through photosynthesis, where sunlight is converted into sugars that keep the plant and the animals moving, but chemosynthesis, a chemically oriented process for generating energy in the biological life form. And chemosynthesis was found at those black hydrogen sulfide chimneys that are spewing that mineral-laden water. And it's chemosynthesis that has started an entire ecosystem and spawned and allowed to continue on the ocean floor where these dark sulfide chimneys are. I actually have a piece of a sulfide chimney here that was given to me by the Woods Hole Oceanographic folks. And I can tell you, to hold that little thing in your hand, you go, wow, this was 3,000 meters down in the bottom of the ocean. You know, and there were giant clams, never before seen until that time, 5 and 6 foot long tube worms that were red from a hemoglobin type compound. Really interesting stuff. Shrimp, you know, all kinds of species that are predatory on each other and also sifting the hot 900 degree Fahrenheit water that was mineral laden, that was squeezed down into the crust by the weight of the ocean above and then percolated back up through fissures after it got down into a real hot zone. And when it percolated out, it was carrying all kinds of amazing chemical nutrients that could be used by chemosynthetic creatures. And that is the life at our hydrothermal vents here. And because of that, we were able to look for life and think about the possibilities of life underneath the surface of Mars, underneath the ices of Europa, the moon of Jupiter, underneath the south pole of Enceladus at Saturn, where we're seeing similar compounds spewing out of the geysers from Enceladus, similar compounds that are found here on Earth, that are, well, systemic and endemic to life. So it's a lot of really interesting data to sift through. And eventually I'm looking to have another degree in planetary science, because I think that makes more sense for where I'm going in the outreach department, because people deal with Earth first. So I would like to talk to people about that and share this type of stuff. And when Daryl and Amanda and I do SkyTour Radio, we often talk about these things. And, you know, we try to be more conversational rather than lecturing, because, you know, people get tired of hearing me talk all the time. So I'm happy to give other people a turn. That's why I'm asking for questions, and if Daryl can answer them, he'll answer them, you know. So once again, like I said, if you have questions, feel free. I'll go take another photo now. And now I'll shut up. Oh, Daryl, that's pretty. Look at. Now, see, this is filter number 1, Daryl. See the Syrtis Major here. And what was this down here you said?
Terra Cimmeria.
Terra Cimmeria.
Cimmera, Cimmeria.
Okay.
That's where Conan was from.
Okay. Was that Sumeria?
Cimmeria.
Was Conan from
He was a Cimmerian. Cimmerian. Cimmerian.
All right. Not to be confused with ancient Sumeria like here.
No.
Sumeria. Wow. Looks pretty though, huh?
Try number 2 again.
All right. Why don't we do that? Okay, we're going to go back and go to the second narrowband filter, which will be a little wider, which is why we're going to have to drop down the exposure. And the reason Daryl likes the shorter exposure is because that the longer exposure, if the sky's a little bit wavy or unsteady, well, you can see when my hands are moving. If you take a picture at a 30th of a, or a, you know, a third of a second, then that's going to smear, because a third of a second happens while the thing's moving. But at a 25th or a 30th of a second, then you have less of a chance. So maybe they'll be sharper. That's
Well, each and every exposure is a roll of the dice.
exactly, because this is what it looks like with the other one, and this is what it looks like with this filter.
I find the number 2 a little more pleasing, actually.
Yeah, I don't disagree. So, did you get your Mars filter?
I did.
Ooh, did you try it?
Not yet.
Ooh.
I was saying while you were outside moving the dome that I was going to set up the 5-inch Mac last night, but I couldn't find the screw to attach the scope to the tripod, and I found it later. But anyway, I was going to try the Mars filter last night, and it was cloudy here today, and after sunset, the clouds broke, and it looks like it's a clear night out right now.
Well, do you want to go try it?
Maybe after we end the stream.
Okay. Well, we've been going for almost 3 hours, so if you want to break and go do it, that's fine. Won't be offended if you want to go play with your telescope. For crying out loud, I want you to get that thing out.
Well, it'd just be the 5-inch, and being a Maxitov telescope, it has a ton of glass in it, and it takes forever to cool off.
That's true.
I think that's a very good picture right there.
Yeah, look at that. Well, why don't you tell folks about the Maxitovs, because, you know, this telescope we're using here in the dome it's called a Schmidt-Cassegrain, or an SCT for short. And the Schmidt-Cassegrain is one style of telescope, and the Maxitov is another. And then there's Newtonian reflectors, and then there's refractors. I mean, there's so many different kinds of telescopes. I'm not sure what we'll get for the third scope out in the Arizona Dome. The first scope in the dome, Arizona building, the first scope is the one we're using tonight. The second scope is going to belong to another streaming group that is going to be renting a pier monthly from me. And the third pier location is going to be another scope, Daryl, that I certainly can't get now. I'd have to wait for some foundation support. But I want to make it a scope that's going to be able to show us some beautiful wide fields. Maybe a telescope sort of like an astrograph, which for those that don't know what that is, that's a telescope that usually very fast shows us somewhat of a wide field, and fast photographically, not speed-wise. It's not like that. But I want them all to be remotely controlled, so people can, not have to be there to run them. Because out in the desert, there's rattlesnakes here. Then, you walk out there at night and you're always looking down with flashlights. You've got a stick with you to make sure you can always, little prongs on it to make sure you can always get something out of your way if it gets in your way or tries to come at you. There's coyotes and lynx and mountain lions, but no bear. Here, I got chased into a house by a bear, but you know what? Out there, not a whole lot of bears. But, the concept between an SCT and a Moxitov are a little bit different, but you know, if you want to tell people the difference, feel free.
Mark's telescope is called a Schmidt-Cassegrain, and what that means is there is a thin, sort of a lens-like glass plate in the front. It's called a corrector plate. Then there's the main mirror is in the back, and it's donut shaped. There is a hole in the center. On the back side of the corrector plate, there is a second mirror, which catches the light from the primary, and then aims that converging beam of light out through the hole in the back of the primary to the back end of the telescope, where the eyepiece or the camera in this case would be. A Moxitov is, strictly speaking, a Moxitov Cassegrain. It also has a donut-shaped primary mirror in the back, but instead of the thin corrector plate in the front, it has a very thick, it's called a meniscus. It's a very thick piece of glass with a particular curve to it, and instead of just a mirror attached to the back, it has a mirrored spot on the inside side of the corrector, the meniscus, which also focuses the light out the back. And they tend to be higher F ratios than Schmidt-Cassegrains do. Mark's telescope, I believe, is an F8.
It is.
You see a lot of Schmidt-Cassegrains are F10.
Yeah.
That's just like the F ratio on a camera lens. While a lot of these Moxitov telescopes are, my little one is an F13.5, which is, you're getting to be a really big focal ratio. And that 8-inch Moxitov I had for the 2003 Mars apparition was an F15.5. And that had a very narrow field of view. It was made for looking at small objects like planets.
Mm-hmm. This is the Moxitov right here. Let me see if I can get a diagram that's a little better. Yeah. So this is the Moxitov, and let me see if I can grab the edge. No, that's as much as it'll go. Oh, you're seeing just the edge, but there's a big thick corrector plate that he was talking about to the right of this image that I just can't seem to drag over here for you. But I was trying to dig for an image to show while you were talking about it, you know.
Yeah, the Moxitov front, I guess you could call it a lens. It's they call it a meniscus. Has a certain curvature to it. I forget the fine points. It may be, I forget if it's parabolic or hyperbolic. And the primary mirror may also have a different curvature to it also.
Yeah.
I don't remember the details. But with that thick plate in the front and the primary in the back, it just has a ton of glass in it. And they take a really long time to cool down to ambient air temperature. And telescope will only really perform at its best when it's cooled down to ambient air.
Right. Well, that's actually, thanks, Daryl. That's that's helpful, especially if people are thinking about getting telescopes. They can understand that it's gonna be more than just a run the Walmart. These telescopes can cost thousands of dollars. The one you're looking at in our dome here, this one is one such telescope that was thousands, and I've actually modified it greatly since then, adding electronics to it that I've made here to do some of the remote stuff we're seeing. And I'm a big fan of microcontrollers, so if any of you know about the Arduinos, Arduino, Arduinos, they're little microcontrollers. It's how you make it's how you make electronics do physical things. Like when you push a button in a hallway, and somehow an elevator car is now coming down to pick you up. That's making, pushing a button makes a mechanical thing do something. How does that actually happen? What transmits the signal to the elevator car, and how's the elevator car's intelligence know that, okay, in this bank of elevators with like 4 or 5 elevator cars, which one is closest, and how does it know to bring that one? All of that, gives you an idea of just the complexity of trying to get hardware to operate by having an interface with some type of microcontroller, and then the human being at the other end of it pushing buttons or telling it what to do. See if I can give you an example of that too, because I actually did something that, here is, for instance, this is the telescope program I wrote to run the dome. Okay, I actually set up motors called stepper motors to actually do things, and I have relays that I use that are basically, a relay is just a switch, but like when you click a wall switch, the light goes on. Well, you can imagine you could send a signal to something called a relay, which in turn would make the same connection that you would make when you flip the wall switch, right? And that's what this program is doing. It's flipping lots and lots of wall switches. It's doing it in a particular order and not letting us do anything out of order. Because, for instance, you don't want to be able to turn the telescope on and stick it up in the air and then take the roof off. You slide the roof off, you'll shear the telescope right off. So one of the no-nos is that you don't allow the roof to move unless the telescope is in its known parked position. Parked, stopped, and off. Okay? Only then can you move the roof on or off. So the roof would have to come off first, in other words. And the software takes care of making sure that you haven't done anything like that. And then if the roof is off, you can then turn on the power. And that's all part of writing, rules in your software to make sure that you're doing the right thing. So the only thing I can't do from in here with this scope right now is to rotate the dome. But as I've told you, I don't want to rotate the dome. I want to get rid of the dome. I actually had another fiberglass 8-foot dome for sale on the Facebook Marketplace just this past couple days ago. It was on there for maybe a day and a half, and somebody snapped it up, okay, and they paid for it too. And then they drove all the way down to Connecticut from Saratoga, New York, a 4-hour trip, and in a truck, and they picked it up and brought it back. So clearly people want to put things in domes still, right? But if you're going to be in the dome, it's one thing, it's great. But if you're doing an automated thing, it's not so great. This particular dome system, it's great, it's wonderful if you're in there, you're going to man the dome. But if you're not, it's not quite there yet. It's not quite there yet. It's made of polystyrene, and out in the desert, we get winds that can approach 80 miles an hour just from thermal heating on the desert floor over the course of the day. And at night, you get these winds that'll come whipping through there at 80 miles an hour at the highest. It's not that often, but probably like last month, Chuck, the scientist who lives, and that's his property out there where this is going, he said, yeah, we had an 80 mile an hour gust here today. So you got to be really, really careful about how you build an observatory out there. It can't blow down, and we're actually bolting the walls right down to the concrete using these special bolts called Hilti bolts. And then we're going to brace the walls from inside, and then we're going to make the roof with encased tracks so that you it can't ever blow off because it's going to be held on by the tracks, which are going to be very, very high end. Hey, Fantasy XST. Fantasy's here. Hey, Fantasy. How are you? And Shiver Canada. I saw you here earlier, and I just didn't say hi to you. I apologize. I missed you. So that's going to be the case. Now, here's our beautiful Mars. You can see this gorgeous view. I'm take another shot because Daryl was about to ask me to take another shot. I feel it. He would have been right to ask.
Actually, I was about to comment that, and you can still see it in this one. I'm not sure which was sharper. There's actually some pretty sharp detail along the north edge of that whole dark feature area.
Yeah, like right here.
There, all the way down to the about 4 o'clock where it's crossing the limb of the planet.
Yeah, that's pretty cool.
Can you go back to the last image, see which one is sharper?
Okay, here's the last image. I do believe the next one. This one looks sharper.
You think?
Yeah. I do believe that's sharper. That's the sharper image. Catalog. Very nice. That's pretty. Let me just take another shot. See, Mars is as high in the sky as it's probably going to get for us right now. It's really on its way. It'll probably be on its way down after this. Fantasy, we got shots like this, but oddly enough, depending on the seeing that you have in the sky, Fantasy asked if we got any really good shots of Mars, but we did get some really nice shots. But oddly enough, like I said, the seeing wasn't all that good for some of those days. So even though it might have been closer, we're seeing it better tonight than we did on other nights, perhaps. I think this is one of the better nights, don't you, Daryl?
Yes.
Yeah. Very cool. And we're actually seeing some. We're seeing some emergent detail coming from around the planet. And
to the left of Syrtis Major.
Yeah, that's going to be Valles.
That's sort of the root of Sinus Sebaeus there, and that touches onto Terra Meridiani.
Yeah, and then we got Valles Marineris still around the other side right now. We'd have to look at it at around 3 a.m. to see Valles Marineris in full on, I would think.
Try another one.
No, twist my arm.
Yeah, see, that one's not as good.
No, we're suffering from the seeing on that one. This is why you take many pictures. That's a little better than the previous. So the most previous one is the one that was a little soft. And then before that, though, we had this, which is really quite exceptional. Look at that.
Yeah. The light area immediately to the right of Syrtis Major is Isidis Planitia, and farther to the right is Elysium Planitia,
which is famous.
And there's actually several, I think, volcanoes in Elysium Planitia.
Yeah, which we can't see because they're always. I would think if they were face on, we might have been able to see Olympus Mons and maybe some of the other Tharsis segment volcanoes there.
Well, I've kind of noticed across a lot of the images, if not all of them, that it looks like a dark spot to the upper right of, and I don't see it in that one, of a dark spot area, dark area to the upper right of Syrtis Major.
I mean, like here?
Yeah, I think I see it there, and that might actually be Elysium Mons. It's in the right area,
Mm-hmm.
according to the map. But then you have Syrtis Major. Again, it looks sort of like an upside-down Africa there.
Right here.
And Terra, I can't keep them all straight. Terra Tyrrhena. If you imagine Africa as being upside down there, yeah, the North Africa part is Terra Tyrrhena.
And Hespera down here.
And then Hesperus, Hesperia Planum.
Hesperia Planum, yep.
And then Terra Cimmeria is farthest over to the lower right.
Barely see it.
Probably going around the planet by now. But yeah, this new stuff is coming up in the left now, in the west.
Yeah, so
the planet is rotating west to east, left to right.
Yep.
And what follows Syrtis Major is Sinus Sabaeus.
Right, which is over here.
Yes.
And then we'll have, beyond that, on the other side still, we have the largest rift valley in the solar system, Valles Marineris. That's pretty.
I have half a mind to, if I were to set up the Mac tonight, I mean, I could take a quick look, but what I'd probably do is leave it outside overnight, let it cool down to ambient, and then get up early and look tomorrow morning. Take a look at the other side.
That's a great idea. And then you can report back to all of us.
Well, can't guarantee anything.
That's all right.
Plus, I don't have a motor drive. It's just my camera tripod, and going to be chasing the planet across the field of view constantly.
But are you using the new Orion mount you got?
No, I'm still waiting on parts.
Oh, okay. Marianne's back.
Hey. Oh, welcome back, Marianne.
Yeah, she was going down to Benson, Arizona to see friends Glenn and Laddie, and so she's there now. That's good. Hi, Glenn and Laddie. Just, if they can't hear me, well, pass along that I say hello to them. They're good friends of Marianne. After all, she just drove, 25 hours to get there. Just kidding. Benson, Arizona from where she is in Mesa is probably a couple hours anyway. But she'll tell us. But thanks for coming back in. That's very kind of you. Just don't tell your friends you're, hanging out with us when you're there to see them. Well, this is a pretty shot, Daryl. There's some
a little
detail.
soft.
There's some detail in this one. Isn't it amazing how fussy we get now?
Well, chasing the seeing.
That's what we're doing. Okay, let's see now. Okay. I'm going to darken it up just a little bit. Go to a 40th of a second. Okay, we'll stick to a 30th for this moment here. Let's see. It doesn't look bad, Daryl. Okay, let's go back, and I want to check out filter number one more time. Okay, but we have to take the risk that the seeing is bad. But you know what? Because it is about as high as it can get, this will be about the best it'll be. So let's see what we get. I don't know. I'm seeing multiple tonality in there. I see darker and lighter, lighter grays, and then the reds of the rusty surface. Just incredible. I'll be honest, I've never seen Mars this good at all until we started looking at it.
Uh-huh.
Yeah. Marianne says it was a 2.5 hour drive. I said a couple hours at least. Yeah. That's cool. All right, Marianne. Well, I'm glad you're there safe and sound. You got to stay safe because, you're very important to SkyTour LiveStream West, All right. So that's cool. Wow. Well, we've gone for 3 hours and 15 minutes tonight. Saw some really cool things. But I have to get up earlier tomorrow. So I think I'm going to have to call it a night, Daryl. How are you doing?
Oh, it's getting to my bedtime, actually.
Yeah. Well, that's how it works. That's how it works, Anyway, guys, I hope you enjoyed tonight. We enjoyed having you for sure. It's always wonderful when Daryl can join us and be part of this because he's, like I've said before, he's an astronomer's astronomer. So I think that's a good testament to the fact that he can talk to you the way you need to be talked to, and that's what we pride ourselves on, is being able to share things with you in a way that you can understand them. This is good music for the Martian Mars,
Kind of reminds me of some music from 2001.
Oh, you mean atmospheres?
I'm sorry?
And yeah, remember the cut atmospheres in 2001?
That could be what I'm thinking of, yeah. Yes.
Yeah.
Yes.
Yeah. You would have the words and then this, that over this in the background. Wow. I'll tell you, I would not be doing this if it wasn't for you guys. You guys just made all the difference. You're fantastic, all of you. So I want to thank you guys for coming out and hanging with us tonight. I had a good time. I have to go close up the dome and everything. Something I wouldn't have to do, when I won't have to do when I actually convert it to a roll-off roof. Because I have a system in there to just hit a single switch and shut the roof, when we're ready. And I can do everything I have to do from inside. And that's what I want, So we're heading there. Arizona's going to have all that, and I'll be able to control it from here. And I'm currently over 2,500 miles from Arizona, but I'll be able to control it from here just fine, So you guys have a good night. Daryl, thank you so much for being part of SkyTour LiveStream. As always, you make it a wonderful place to be.
Well, thank you for having me.
Oh, of
Good
course.
night, everybody.
You guys have a good night, and we'll be back on the next clear night, which if it's tomorrow, I'll see you tomorrow, because we stream on every clear night. So see you guys later. And in Arizona, we get 300 clear nights a year. So you know what that means. Oh, yeah. So you'll also get to see some research, too. But you guys have a good night, and we will talk to you later. I'll leave the Mars image up on the screen here for you. But you have a good evening, and make sure you stay safe out there. So bye-bye. Talk to you maybe tomorrow. See ya.
Night, everybody.